Welcome to our Computer Network Security full course by Simplilearn. In today's digital age, securing networks from hackers, protecting sensitive data, and defending against cyber threats is more important than ever. And this course is designed to equip you with the knowledge to just do that. You will master everything from basic networking concept to advanced cybersecurity protocols and the best practices. So we will teach you how to identify vulnerabilities, implement robust security measures, and protect against cyber attacks like a seasoned professional. Starting with essential networking principles like Ethernet, OSI model, and switching techniques, we will dive into security measures like phishing attacks and penetration testing. You'll also gain hands-on experience with tools like Wireshark and also explore Linux file system to solve real-world security challenges. And guys, by the end of this course, you will have the expertise to secure networks and confidently step into the world of cybersecurity. So hurry up and let's get started. But before we move on, if you're interested in stepping into one of the most in-demand fields, then the Advanced Executive Program in Cybersecurity by Simplilearn is the perfect opportunity for you. And in just 6 months, you will gain expertise in ethical hacking, penetration testing, ransomware analysis, and advanced defense strategies through a hands-on industry-relevant approach. This program, offered in collaboration with IIIT Bangalore and IBM, features live interactive classes, real-world projects, and industry-recognized certifications. You will also benefit from masterclasses by top IIIT Bangalore faculty and an ex-NPCI expert, diving into cutting-edge topics like GenAI with cybersecurity. So whether you're looking to start or advance your career in cybersecurity, this course will make you job-ready with practical tools, projects, and certifications to help you stand out. So guys, hurry up and enroll now. You can find the course link in the description box and in the pinned comments.
Welcome to this video on the basics of networking, where we cover the multiple hardware elements and topologies of how these network setups work. Let's take a look at the things we will be covering today in our video. We start by learning about the different network types and the importance of an IP address in a network environment. Next, we cover the significance of switches and the working of routers in a network. Moving on, we cover the explanation of subnets in a network and the importance of network address translation or NAT. Finally, we understand how firewalls work and the distinct use cases of DMZs and port forwarding. Before moving forward, ensure you're subscribed to our channel and have hit the bell icon to never miss an update from Simplilearn. So let's get started with the two major types of network that should be considered basic knowledge for someone starting out with networking: LANs and WANs. The first variety of networks is a local area network, also known as LAN. It comprises of cables, gateways, switches, routers, and additional parts that allow these devices to connect to private servers, cloud services, and other LANs via larger networks. The growth of virtualization has also sped up the creation of virtual LANs, which let network managers divide and logically organize network nodes without having to make significant modifications to the infrastructure. The computers in each department could be conceptually linked to the same switch in an office with many departments, be it accountancy, IT support, and administration. Still, they might be segregated to operate separately. The benefits of a LAN are similar to those of any collection of connected devices. They may access and even control one another, exchange files, print to shared printers, and utilize a single internet connection. To better understand this logic, let us take a sample structure. We can see the various components of a local network connection in this picture. And now we can see three different devices: a system, a laptop, and a printer. So we have these few devices that need to be connected to a single local area network. Now, to identify these devices inside the network, we need to assign an identifier to each device. So this is where an IP address can help. An IP address is a lengthy string of digits allocated to any device connected to a network that utilizes Internet Protocol as the communication medium. It's the digital equivalent of your house or workplace's mailing address. The addresses are divided into 4 sections separated by dots. Each traditional base 10 numeral portion represents an 8-bit binary integer which can range from 0 to 255. These 4 integers are expressed in normal decimal notation and then separated by dots. However, computers work with binary numbers, meaning zeros and ones, and each number in an IPv4 address represents an 8-bit binary integer, which is why none of them can be more than 255. The distribution of these IP addresses is not just limited to LAN. Every device which is a part of a network will have its own IP address as assigned by the network administrator. As seen in the picture, we can now identify each device individually by their designated IP addresses. Now, with the primary purpose of a network being the ability of multiple devices to communicate and exchange information with each other, these IP addresses serve only half the purpose, since allotment and identification of these addresses need to be managed automatically and on demand. If the laptop shown on the left of the screen wants to use the printer in the network, it needs to know which particular device, or more precisely, which particular IP address to communicate with. This is where a switch comes into play. It takes the role of the delegation of commands in a particular network. Let's learn more about switches in detail. A network switch joins devices in a network, such as computers, printers, wireless access points, and allows them to communicate with each other by exchanging data packets. They can be both physical hardware devices that handle real networks or software-based virtual devices. The vast majority of network equipment in modern data networks are switches. They link desktop PCs, access points, automated equipment, and some IoT devices via wired connections, such as card entry systems. They link the computers in data centers that run virtual machines or VMs, as well as the actual server and most of the storage equipment. Based on the type of switches employed, they can either differentiate between network devices using either their IP addresses or MAC addresses, which are separate types of addresses allotted to each hardware device, irrespective of the network it is connected to. Now that we understand the major parts of a local area network, a major query that may come to your mind is how can these local networks then communicate with other networks? A router is employed at the forefront of every network setup to facilitate communication between foreign networks. This router can then be used to connect to the internet so we can communicate with the loved ones from the comfort of our own homes. So let's learn a little more about routers. The router is a physical or virtualized internetworking equipment that receives, analyzes, and transmits data packets across computer networks. The router checks a data packet's destination IP address and utilizes headers and forwarding tables to determine the best path to transport the packet. Consider the router to be an air traffic controller and data packets to be airplanes flying to various airports or networks in this case. Each package, like each jet, has a unique destination and must be steered to its destination as effectively as possible. A router helps direct these data packets to their intended IP addresses in the same manner that the air traffic controller ensures that flights arrive at their destination without getting lost or experiencing severe disruptions. A router employs an internal routing table, which is a collection of pathways to multiple network destinations to properly direct packets. It scans the header of a packet to establish its destination, then consults the routing table to find the most efficient way to their destination. The packet is subsequently sent to the next network along the route. A router also has an IP address, which is often called as the network gateway. A crucial part of the networking setup is determining whether a particular piece of hardware is a part of local network or a foreign device. As you already know, specific IP addresses exist for each device in a network, be it a local or wide area network. All these IP addresses must belong to a particular range of addresses, which are often known as the subnet or subnetwork, and which help determine the overall range of a local area network. For example, the IP addresses that can be seen on the screen right now belong to a subnet that is 255.255.0.0. The first two flags denote fixed values that must be present in every single IP address of every single device in this particular network. In our case, the 192.168 is the consistent factor in every single IP address shown on the screen. This implies that if the devices can connect to a piece of equipment with an IP address and it starts from 192.168, that device will most likely be in the same local area network. The last two places are the free ranges in this example, which means they can be any number less than 255, further helping the router and switch differentiate between multiple IP addresses in a network. With that being said, we can now take a look at how wide area networks work. A wide area network, or a WAN, is in its most basic form a collection of local area networks or any other networks that interact with one another. A wide area network is essentially a network of networks, with the internet serving as the world's biggest one. However, When a router communicates with devices outside a local network, it tends to mask the internally allocated IP addresses and uses a single public IP address for all the devices. This process is called network address translation or NAT IP allocation. A network address translation is a method of translating one IP address to another while these packets are in transit through a router. This improves security and reduces the number of IP addresses required by a company. Once a router receives some particular information that must be transmitted to a local device in the network, it checks the internal routing tables to determine the correct internal IP address and the correct destination to send the externally received data to. But let's say a device on the external network or a wide area network wants to communicate directly with a device from the local network. This cannot be allowed since this can be a very big security risk for devices in a secure environment. All of this entry and exit rule creation and handling can be taken care of by a firewall. A firewall is a type of network security device that analyzes the incoming and outgoing networking traffic and allows or denies data packets depending on a set of security rules. Its objective is to provide a barrier between your local network and external traffic, such as the internet. The most common sort of firewall, which are packet filtering firewalls, check packets and prevent them from getting through if they do not meet an established security rule set. This sort of firewall examines the packet's destination and source IP addresses. If the packet fits an allowed rule on the firewall, they are permitted to access the network. But let's say we, as users, want to allow external requests to reach individual computers or devices on our local network. There are two ways to facilitate this behavior. The first way to go through this step is by using a DMZ, which stands for a demilitarized zone. Instead of communicating directly with the local network device, the external data is sent to the router instead. The router will have created a DMZ subnetwork with only those devices added to it that require the external information to reach them unaltered. Once the data is received by the router, it passes it on to the DMZ subnet and subsequently to all the devices which are a part of that subnet. However, since the external data can reach devices in a network without any firewall checks if they are part of the DMZ subnet, the security risks associated with this method are very large compared to the second variant, which is port forwarding. Port forwarding is a method of granting external devices access to computers on private networks. It accomplishes this by translating an external IP address and port to an internal IP address and port. All the devices talk to each other and the network gateway using the IP addresses and specific ports. For example, the TCP/IP protocol, basic internet usage, uses port 80 on every network. Similarly, we can create additional firewall rules to open up certain ports for external devices to communicate with. If the designated ports are open during communication, the firewall will allow the external network device or server to communicate directly with the local network device without any hindrance. That's all we really need to know for now about the basics of networking.
With the advancement of technology, everyone is constantly accessing data and information on the internet, be it in video format, audio format, or a text file. And in today's topic, we will look into something similar. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's look into the agenda for today's video. To begin with, we will look into what is Ethernet. Moving on with seeing what is the use of Ethernet, different types of Ethernet, and looking into the working of the Ethernet cables. Advantages and disadvantages of using Ethernet, and lastly, difference between Ethernet and Internet. Now let's look into the first heading. What is Ethernet? Ethernet is a form of communication network that uses a wired medium to connect devices for data exchange in a network. For example, LAN, also known as Local Area Network. Also, WAN, known as Wide Area Network. Ethernet also applies different protocol on the data to be transmitted over the communication channel efficiently and smoothly. Moving on Let's look into why to use Ethernet. As we now know, the Ethernet is a mode of connection for multiple devices to share and exchange data. But using this way of transmission also has its benefit. For example, the Ethernet network provides us with a high-speed connection for sharing data. Ethernet also provides the user data with a secure channel for transmission. The data that is transmitted over the Ethernet channel is reliable and has rarely faced any issues at the sender side. Let's move on to the next heading. Now we will look into different types of Ethernet. In general, the Ethernet is divided into three different types. First is the fast Ethernet. This type of Ethernet operates on a twisted pair cable with a data transmission speed of up to 100 Mbps per second. Fast Ethernet connections are used for personal connections or used in companies that require low internet connection. Moving on, we have Gigabit Ethernet. This connection is used for high-speed internet connection with a speed ranging from 1000 Mbps to 1 Gbps. It is an upgraded form of fast Ethernet. And the last type is switched Ethernet. This Ethernet type installs network devices such as switches or hubs so as to improve the network transmission. The transmission range for switched Ethernet connection is around 1000 Mbps to 10 Gbps. Now let's look into the working of Ethernet. Ethernet services specifically work in the first layer of the OSI model, that is known as the physical layer, and the second layer of the OSI model, also known as data link layer. Functioning of the Ethernet can be divided into three different parts. First step being acquiring the physical address, that is MAC address, media access control address of the sender and the receiver device. Then the second step is to check the data security, quality of the data, and the connection speed of the transmission channel for efficient and smooth transmission of data over the network. And the last step is to check network traffic and detect any error that occurs in the communication channel. To solve these issues, if occur, CSMA protocols and other protocols are used. For example, the CSMA protocol is used in case of packet collision in the network channel. Now let's look at a simple Ethernet model for further clarification of the steps. But before we begin with the model, the point to be noted is the transmission of data over the Ethernet channel is divided into two parts, frames and packets, where packets represents a unit of data in the network, whereas frame refers to a collection of data packets being transmitted over the channel. And the application of Ethernet services, which includes security, traffic check, and protocols being applied on the data. And that is when it reaches the receiver end. Moving on, let's look into advantages and disadvantages of using Ethernet. For advantages we have, cost of installing Ethernet connection is low in comparison to other network channels. The security of the data being transmitted over the Ethernet channel is maintained. As for disadvantages we have, it is suitable only for establishing short distance communication network due to high requirement of hardware resources. Whereas Ethernet is also not suitable for sharing real-time data and information. Let's look into some more advantages and disadvantages. Ethernet is suitable for maintaining the data quality of the information being transmitted. It also provides high-speed data transmission option for the network. For disadvantages we have, the network traffic issue is a drawback of installing Ethernet cables. Troubleshooting faults and issues in the internet cable is also a troublesome work. Now let's move on to the last heading for this topic, that is Ethernet versus Internet. The first difference is connection medium. For Ethernet connection, physical cables are required. That means it uses wired medium for connection. Whereas in case of Internet, it uses wireless medium such as satellites as a connection medium. Moving on, the next difference is network model. The Ethernet is available only for a low distance connection, for example, LAN, whereas Internet is available for all the network connection distances, be it LAN, MAN, or WAN. Let's move on to the next difference, that is network control. For Ethernet, the complexity of the connection medium is low due to the less distance it uses, and also provides much efficient transmission of data over the communication channel. Whereas for Internet is a large collection of networks and hence require large group of administrator for control. The last difference between Ethernet and Internet is network security and reliability. Ethernet connection is a secure network from external interference and provides data security. Whereas in case of Internet, it is an open type of connection, so it is more prone to hacking attempts and less secure network.
Hello Tech Wizards and Digital Explorers. Welcome to a journey into the core of Linux, the operating system powering over 2.3% of desktop computers globally and a staggering 96.3% of the world's top 1 million servers. I am Abhisar and today we are delving into one of the most vital components of Linux, its file systems. Imagine a world where every piece of digital information is meticulously organized, where every byte of data has its own unique place. That world exists right inside your Linux machine. So buckle up as we dive deep into the intricate maze of Linux file systems, exploring how they work, why they are important, and what makes them so unique in the realm of operating systems. In the realm of Linux, file systems like ext4, XFS, and BTRFS aren't just names, they are sophisticated architectures that manage how billions of bytes of data are stored, accessed, and organized. These systems are the unsung heroes ensuring data integrity and efficiency in a digital world. Today we will uncover how these file systems support everything from your personal blogs to the largest data centers hosting petabytes of information. We will explore inodes, journaling, mounting, and more terms that might sound complex but are incredibly fascinating once you get to know them. And now, Linux offers a diverse array of file systems, each tailored to specific requirements. And now, let's explore some prevalent Linux file systems. So starting with ex2, and then we have ex3, ext4, XFS, BTRFS, ZFS, JFS, and then we have RiserFS. So now, starting with the first one, that is ext2. So ext2, Extended File System 2, that is one of the Linux earliest and most commonly used file systems. ext2 has long been a default choice for many Linux distributions. It's known for its stability and suitability for small to medium-sized partitions, though it lacks a journaling feature, which can complicate file recovery post-crash. Now moving to the next file system, that is ext3, Extended File System 3. Building on ext2, ext3 introduces journaling to track file system changes, reducing data loss risk after crashes. It's a popular choice for its stability, reliability, and performance. And now moving to the next, that is ext4, Extended File System 4. As the evolution of ext3, ext4 addresses some of its predecessors' limitations. It supports larger files, quicker file system checks, and enhanced performance for larger disks. Features like journal checksumming also enhances data integrity. ext4 is a default file system in many modern Linux distributions. Now moving to the next file system, that is XFS. So XFS, that is X file system, that is designed for large-scale storage, and XFS excels in performance and is suitable for file systems up to 16 exabytes. It's a top choice for large data centers, offering scalability, reliability, and featuring like journaling and file-level languages. Now, moving on to the next file system, that is BTRFS, B-tree file system. A newer Linux file system, BTRFS supports copy on write, snapshots, and subvolumes, allowing for multiple file systems within a single partition. It also includes RAID and compression support. BTRFS is still under development and isn't as commonly used as other file systems. Next we have is ZFS. ZFS, Zettabyte File System. Initially developed for Solaris, ZFS is a robust system with features like snapshots, data compression, deduplication, and built-in RAID. Renowned for its data integrity and self-healing capabilities, ZFS is not typically included in Linux distributions due to licensing but can be installed separately. Now moving to the next file system, that is GFS. GFS, Journal File System, that is developed by IBM. GFS is known for its performance and reliability. It offers journaling, file level compression, and online resizing, making it a strong choice for high performance systems. And now the next one, that is Resizer FS. So targeted at high performance computing, Resizer FS includes features like journaling, file level encryption, and support for larger files. While known for its speed and reliability, it's less common compared to other file systems listed here. Now moving to key Linux file system directories. So the Linux operating system's file management is predominantly handled through directories, commonly known as folders. These elements are crucial in the Linux file system, serving not just as file holders, but also as organizational tools. Imagine directories as virtual boxes, each capable of storing files and other directories. Directories in Linux play a vital role in providing an ordered, hierarchical framework for file arrangement. This hierarchy commences at the root directory, denoted as / and extends into various subdirectories. This approach allows for a logical and systematic organization of complex systems, enhancing the ease of file management and access. So key Linux file system directories. Each directory in the Linux file system serves a distinct purpose. Here are some of the significant directories. Starting with the number 1, that is root directory. So root directory is the highest level in the Linux file system hierarchy. All other directories and files are nested within this root. Now moving to the next directory, that is bin. Standing for binaries, this directory contains essential command line utilities and programs vital for basic system management. And then we have boot. So here lies the bootloader files and the kernel images necessary for system startup. And then we have dev. This directory hosts device files representing both physical like printers and disk and virtual devices like terminals. And then we have etc directory, that is home to system configuration files. These are utilized by various applications and services. And then we have home directory. It houses individual users' directories, providing personal space for file and setting storage. And then we have library directory. This directory stores shared library files needed by system programs. Next we have media directory, a mounting point for removable media such as USB drives, CDs and DVDs. And then we have MNT, that is mounting directory, that is used for temporarily mounting file systems like network file systems or disk images. Next we have OPD directory, a location for additional software packages that are not part of the standard system. And then we have standard bin directory, a directory for system binaries and administrative tools essential for system upkeep. And then we have user directory that contains user level programs, libraries, documentation and shared data files. So these were the directories in Linux file distribution system. And now here are the key concepts in file systems. Starting with journaling file system. So these systems maintain a log referred to as journal. This log records changes to files that are not yet permanently saved on the disk. This feature is particularly useful for recovering lost changes in the event of a system failure. And the next we have is versioning file systems. These systems preserve earlier versions of files. Essentially, they save file copies based on their previous states at specific intervals, offering a backup mechanism that could be based on minute or hourly updates. And next we have index nodes. An inode symbolizes a file or directory detailing attributes like size, permissions, ownership, and physical locations. And now we'll see the demo for the Linux file distribution system. So for that, we'll open the terminal with Ctrl-Alt-T. And now First we'll see in which directory we currently are in. So we are in home, Avisaruja. So first we'll move to the root directory. For that we'll write the command cd space slash. So now we have moved to the root directory, and here we'll see what types of directories we have. We have bin, dev, boot, etc, opt, run, swap file. So now we'll move to the bin directory. So in bin directory, it contains binaries or essential executable files. So these are the binaries and executable files that we can use in the terminal only. So now, as I will show you, there's a bin and there's sbin also. This is sbin. So now we'll move to the sbin directory. For that we'll write the command cd sbin, and here we see the directories of sbin. So what does sbin contain? It contains system binaries like mount or delete and the user that are used by the root user. So these binaries can be used by the root user only. And then we have other directories, that is library. So to move to the library directory, we'll write the command cdlib, and now we'll see its directories. So what does it contains? It stores common libraries between bin and sbin. So many directories are stored in the library directory only. So then we have another directory, that is user directory under the root only. So to move to that, we'll write cd user. So it says that, so first we'll move back to the root directory, and then we'll move to the user directory. So it says that no such file or directory is present here. We'll just check. I think it's USR for user. Yeah, it's USR. So user directory is named as USR. We'll move to the user directory, and to see the directories inside user, so these are the directories in user. So user has its own bin and sbin directory, and the binaries here are non-essential binaries. And there's a local directory under user. So it contains binaries that you can combine manually. So these are all the directories under root, and you can go to other directories also, as I have shown you the diagram of all the directories under user or under the root that I have shown in the previous thing, so you can check it out. So in conclusion, the Linux file system with its directory structure is a cornerstone of the operating system. It facilitates efficient data management while upholding system stability and security. Linux file system is characterized by its hierarchical tree-like structure with the root directory at its apex. Various file systems in Linux cater to different needs, each with its pros and cons. The Linux directory structure encompasses an array of directories, each designated for specific function like system binaries, boot files, device files, and user files.
If you've ever opened a computer's file manager, you've probably seen something familiar on Windows. It's that trusty C drive with neat folders like program files and documents. On Mac, you get Applications folder, your desktop, and few others. Easy, right? But then you step into Linux and suddenly you're staring at bin, etc, proc, lib, and you're thinking, what alien planet have I just landed on? Now the truth is, Linux organizes its file in a completely different way. No C drive, no fancy icon. Everything starts from a single slash, and every folder hanging from it has a very specific job. And here's the thing, it's not as scary as it looks. In fact, once you understand it, it's beautifully logical. So in this video, I'm going to walk you through the Linux file system structure step by step in plain simple English. No tech jargon overloaded. And by the end, you'll know exactly what each folder does, where to find your stuff, and how it's different from Windows and Mac. So in this video, we'll be covering what the Linux file system is and how it's different from Windows and Mac, starting from the root directory and exploring key folders like home, bin, dev, lib, temp, and many others. We'll also cover simple Linux commands to navigate and explore the structure, and a few quiz questions to make sure you're following along. Now before we get started, here's a quick quiz question for you. When you first boot up your computer, which part of the Linux file system do you think is responsible for starting the system? Home directory, boot directory, etc. directory? You can drop your guesses in the comment section below. Also, if you haven't subscribed to Simplilearn YouTube channel yet, do hit the notification bell and subscribe for more such content by Simplilearn. So let's get started now. Now before we get started, let's first understand what exactly the Linux file system is. You can think of it as the organization system for your computer. Now every file, program and setting on your system is stored somewhere. And the Linux system is responsible for organizing all of that into neat directories and files. It's just like the blueprint for your computer's data storage, telling you where to find things and how they are connected. Just like a library has shelf, labels and categories to keep all the books organized, in the same way the Linux file system works, but with files and directories instead of books. So why do we need this structure? Well, in Linux, the file system is a hierarchical structure, which means everything is organized in layers starting from the root at the top, just like a tree, and the branches off into different directories, each serving a specific purpose. It helps manage data efficiently, ensuring security, and allows the system to run smoothly and quickly. So why are we diving into the Linux file system today? So whether you're new to Linux or a seasoned user, understanding where files are stored and how everything is organized is very important for troubleshooting and system efficiency. Knowing the purpose of each directory will help you to navigate and manage files easily. This video will give you a solid foundation so you can confidently handle tasks and feel in control of your Linux system. Let's have a quick comparison between Windows and Linux. So when you're using Windows, everything feels familiar. You've got your C drive, maybe a D or E drive, and all your files and programs are neatly stored there. File paths uses backslashes like users Alex document, and Windows doesn't care about capital letters. So you can see here in the screen, you can see most of the apps are installed and it's end up with C / program files, right? And also talking about the capital letters, now files.txt and files are treated the same. Most apps you install end up with C program files, so it's pretty straightforward. But here in case of Linux, it's pretty different. The rules are a little different. There are no drive letters. Everything starts with a single root directory. And from there, all your folders and files branch out. File paths uses / like home, Chris, downloads. And it's also case sensitive. So file.txt and file.txt are completely different files here. Now, another big difference is in Linux, everything, your hard drive, your USB sticks, even your keyboard appears somewhere under this slash. You can think of it like this. Now, Linux is a giant tree and this slash is the trunk, and every folder is a branch out here, the bin, etc, home, opt, and everything. Now, once you see the pattern, it actually becomes easier for you to navigate than in Windows. Alright, now let's talk about the Linux file hierarchy structure, or simply how Linux arranges the folders and files. Well, in Linux, there's something called the File System Hierarchy Standard, or FHS for short. You can think of it as a rule book that tells the system where different types of files should go. Now, this standard is managed by the Linux Foundation, and here's the interesting part. No matter where a file is stored on your computer's hard drive or external drive or even a virtual device, in Linux, all of it appears under one main folder, which is the root directory. Now, this root directory is just under a single /. Some folders you'll see only if certain features are installed, like the X window system for graphic, but most of these folders are present in all Unix-based systems, and they generally work in a very similar way. What we'll be focusing on here is how Linux uses them specifically. So let's dive into the structure and break it down step by step. Let's begin at the top, the very first directory in Linux, which is the root directory. Now, what is a root directory in Linux? Well, the root directory is like the main entry point in Linux. It's represented by a single / and everything else in the system connects to it. You can think of the root directory like the trunk of a tree, and all the other directories like branches grow out from it. This is the highest point in the Linux file system, and there is nothing above it. It's the starting point for everything. Now, how does the root directory even work? Well, every file, folder, device, or even a network shared in the system is connected with /. Let's say, for example, your documents, music files, or even your external devices like USB drives, everything will appear under the folder /. But only the root user, that is the administrator, can make changes directly to the / directory. Normal users won't have the permission to modify things out there without special access. Here's an important clarification to make: the root versus this /, the /root versus the normal /. So this is the main root directory, and the root is a special directory. It's the personal home directory to the root user, and it's very similar to how the home username in a home directory is used for other people. You can think of root as the root's user personal workspace within the system. Now, in Windows, we use different letters like C drive, D drive to represent different parts of a system, like your hard drive, external storage, etc. But in the case of Linux, there's no such thing as drive letters. Instead, everything connects to a root directory, even if it's an external devices like a USB drive. This structure makes Linux more unified and flexible, as all the files, no matter where they are stored, are part of one system, which is starting from /. Alright, we are at the trunk of the tree. Let's grab the essential tools we'll need, and they are all in the bin folder. So the second directory we are talking about is the bin, which is essential user command. Now, the bin directory in Linux, it stands for binary, and it contains essential commands that every user can use. So whether they are an administrator or a normal user. These commands are the core tools which are required for running the system and doing everyday tasks for the terminal, which is the command line. But why is bin even important? Well, the commands in bin are vital for working with files and managing your system. Let's say for here, ls, which stands for list the files in a directory. The cp stands for copies, file, or directories. mv means move or renaming files. rm is removing files or directories. Ping means checking network connectivity. grep searches for specific pattern in files, and cat will display the contents of a file. You can see these commands are so fundamental that they are available even in single user mode, which is a minimal state where the system can run in, often used for maintenance or troubleshooting. So what happens if you don't have bin? If you don't have bin, you wouldn't be able to perform basic file operations like copying, deleting, or listing the files from the terminal. Now, these actions would be impossible, making the system unusable for normal tasks. If you're familiar with Windows, bin in Linux is similar, same as in Windows, like how we write this in C drive, Windows System 32 folder. System 32 in Windows holds essential tools like command.exe and other system utilities which are similar to how bin stores essential Linux command. So bin is critical directory in Linux because it holds the basic commands that are necessary to interact with the system and manage file. Without these commands, the system wouldn't function properly. But before you can even use bin, Linux needs to actually start up, and that's where boot comes in. Let's make sure you're following along. So I have another quiz question for you. Now, which of these folders in Linux holds the command that help you manage files like copying and moving them? Your options are home, bin, boot. You can think your answer and you can drop it in the comment section below. Now we'll be talking about the boot directory, which is often called the bootloader and kernel files. Now this is where Linux keeps everything it needs to start from the system. It contains the Linux kernel, the core of the operating system. It holds the grup, which is the bootloader files, the menu you might see when starting the computer. Now it also includes initial RAM disk file, which is the initrid or initrams, to help the kernel load drivers before the main system even starts. Now, without boot, your PC won't even start Linux. Talking about Windows, Windows has boot files like boot mgr and the boot configuration. Okay, the engine is running now. Linux needs to talk to hardware as well. Keyboards, disk, and printers. Now, this happens when they are stored in the dev directory. Now, dev is for the device files in Linux. So in Linux, hardware is treated just like a file. So in hard drives, you have folders like dev sda1, dev nvm. Then you have USB drive, microphone, speakers, keyboards, all have entries over here. Now, talking about the two main components, so there are basically two main type of device files here. First, we've got the block devices which store and transfer data in blocks, for example, hard drives. Then second, we have the character devices which can send data one character at a time, for example, serial ports and keyboards. In Windows, devices appear as E, F, etc. And in Linux, they appear as special files in dev. Now, how does Linux knows how to behave? Now, that's decided in the etc directory. This stands for System Configuration Files. The configuration files, this folder contains all the system-wide settings in plain text. You have your network settings here, the DNS servers, then you have the user accounts as well, startup services like etc, initd, etc. You can also open these files with any text editor because Linux stores configurations as readable text, unlike Windows registry, which is stored in special database. Now we have seen system settings. Now where do you keep your personal files? That's where we have our home directory, which is for personal user directories. Now, every user in Linux gets a personal folder under this home. So if your username is John, your folder would be home, John, and you can store documents, pictures, downloads, and even your personal configurations over here. You cannot just modify other users' folder without any permission. It's just like the Windows C drive where users John in Windows, like how we use it. Now we have seen how this home directory works. Now to run applications, Linux needs shared code. And this is where the lib directory comes in, which is for shared libraries. So lib basically contains .so shared object files, which are similar to DLL files in Windows. Now these are used by programs in bin and sbin to work properly. Let's say, for example, if bin ls needs to print colored output, it might use a library in this lib directory to handle colors. Next, we'll look at where Linux puts removable devices, USB drives, CDs, and that's where media directory comes in. This is also called the auto-mounted devices. So when you plug in a USB or you insert a CD, Linux automatically creates a folder inside media and it mounts it there. For example, we have media John my USB. Now Windows will just give you the device a new drive letter, whereas in case of Linux, it will treat it as a part of the single directory tree. Let's move on to the next directory. Now, sometimes you don't want Linux to auto-mount devices, right? And that's where the mount comes into play. This is also called the temporary mount point directory, which is used by system admins to manually mount devices or network drives. Also, it's great for temporary use and it also doesn't even affect the media directory from here. Talking about the next directory on our list, which is the opt optional software. We all know that some software doesn't come with Linux by default. We keep it that in this optional software directory. Third-party software and its files are stored here. Let's say, for example, installing Google Chrome manually might put it in this opt Google Chrome directory. So this was for this directory out here. Next one, we've got the sbin, which stands for System Administration Command. Now for system maintenance, admins use special commands. These live in this folder. It contains commands like IP tables, firewall, fdisk, disk partitioning, and reboot. So if you want to access the directory, you want to first initially start up and access the root. Next one we've got on the list is SRV, the service data root directory. So what it does is it basically stores files for services like websites, SRV, www, or FTP servers, SRV, FTP. Now you must have heard about this directory, which is the temporary files TMP. This is used by application to store short-term data, and also it clears automatically after a reboot. Then we've got this user directory, user programs and data. So the first one we have is the user local. These programs are installed manually from the source. Second, user program data directory, we've got user bin, the user commands which are not in the bin folder. Then we've got the user sbin, where the admin commands not in the sbin. And then we have the user lib, which are related to libraries. The next up, we've got this process information directory. So this is a virtual file system showing live system data. So this particularly will show your CPU details, your memory stats, and information about a specific running process. So now that we have covered all the important file directories, I'll show you a quick Linux command cheat sheet. So here, first up, we've got this ls, which stands for list directory content. Second, we've got this cd directory, which is the change directory. We have pwd, which stands for print working directory. cp source dest, it stands for copy files or directories. Then we've got mv source dest, which is move rename files. RM is for remove files or directories. Stop is for displaying system processes. PS aux is for showing process status. chmod permission file is for changing file permissions. chown user group file is for changing file ownership. grep pattern file is for searching text patterns. cat file is for displaying file content. ping host is to test network connection. SSH is for securing shell connection, and at last we've got wget URL to download the files. And that's the full Linux system tool. Now you know exactly where Linux keep your files, settings, and even hardware. Once you get comfortable with these, navigating Linux just feel as natural as browsing folders in Windows. Maybe even better. Now that's a wrap on this video. If you like this video, do hit the notification bell and subscribe for more such video by Simplilearn.
With the increase in the sharing of data and information online, there is a need to maintain proper routing and efficient data transmission from sender to the receiver node, which comes under the scope for today's topic. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Let's take a look at today's agenda. To begin with, we will look into what are switching techniques, why to apply these switching techniques, and in the end, we will look into different types of switching techniques. Let's move on with the first heading, that is, what are switching techniques? Switching techniques are network techniques responsible for overseeing the transmission of data over different communication channels. They are also responsible for choosing the best route for data transfer. Next, we will look into why to apply these switching techniques. Using the switching techniques, we can choose the best and the most efficient route for data transfer in the network. For example, if we want to send some data from node A to node B, we can do so by moving from node A to a switch, then node D, then to node B. But doesn't this seems like too long? This is where the switching techniques plays its role. Using the switching technique, we can choose the smallest and the most efficient way, that is, node A, switch, then to the node B. Next, we will look into different types of switching techniques. Switching techniques can be divided into three primary types. The first is circuit switching, that requires a predestined path for data transmission. Then we have message switching, which integrates the destination address with the data for transmission. And in the end, we have packet switching, that divides its message into smaller units known as packets. Packet switching can further be divided into two different types, that are virtual switching and datagram switching. Now let's look into some details regarding each of the types. On the first note, we have circuit switching. In circuit switching, for data transmission to occur, a pre-established path is required between the sender and the receiver node. For example, assume that we call someone. Then this request is sent over to the network switches. and a route is to be established for the signal to pass through. After the system assigns a route for the signal to pass through, then the receiver receives the call from the caller side. This is how it works. Now let's look into some points to remember about circuit switching. For circuit switching, we require a dedicated channel established between the source and the destination node for the network to pass through. The data transmission can take place only after the path is established. And the last point to remember is, other than the sender and the destination node, no node can interfere with the transmission of data to the established route. Let's look at some advantages and disadvantages of applying circuit switching in a network. For first one, we have advantages. Data transmission in circuit switching is sure to be established due to the predestined path. Circuit switching is preferred for long and continuous transmission of data due to the pre-established path route. Then let's look into some disadvantages. The time required to establish the connection is quite long due to the time required to establish a path. Also, due to the continuous transmission of data in circuit switching, more bandwidth is required for maintaining the connection. Let's move on with message switching. In message switching, no predestined path is established between the sender and the destination node in the message. This technique integrates the destination address into the data transmitted and is shared over the network. Let's look into the setup to better understand the working of message switching. For first step, the sender node integrates the destination address into the message. Then the whole message is transmitted to the switching node in the network, where it gets stored for the next transmission. And similarly, like the second step, this transmission of data is done over the whole network. And finally, through the destination address in the data, it reaches the receiver node. This is how the message switching works. Let's take a look at some points to remember about message switching. In message switching, no predestined path is established. It uses dynamic routing as the message is transmitted through the communication channel in real time. Each node in network switching stores the data unless it is transferred over to the next switch node. Let's take a look at some advantages and disadvantages of applying message switching. To begin with, let's take a look at the advantages. The size of the data that can be transmitted over message switching is variable. In message switching, the use of bandwidth is done in an efficient manner. Now let's look into some disadvantages. For message switching, the nodes that are known as the switch node is to be provided with sufficient storage memory. There is a delay in reaching the destination due to the message technique, that is, the message has to stop at each of the switch node before it is transferred over to the destination node. Now let's look into the last switching technique, that is packet switching. In packet switching, the message is broken into smaller data units known as packets. These packets are appended with relevant network details for the transmission over the network. Let's look into the working of packet switching. We know that in packet switching, the data is broken into smaller units packets, which each packet is given a sequence number for identification. These packets are integrated with required sender and receiver address and switching method to choose the smallest route to reach the destination node. These packets are then recombined at the destination node in the correct sequence order. Now let's look into some points to remember for packet switching. For packet switching, all the data packets that are provided with unique number for identification at the receiver end, that is 1, 2, 3 and 4 in the previous example we just used. Packet switching chooses the most shortest path possible for the data to reach the destination end. In case we have unreached packet or some unattained packet, the whole message from the sender side is sent again to the receiver end. Now let's look into some details regarding advantages and disadvantages of applying packet switching. Advantages of using packet switching is it provides rerouting in case the network node is busy. It also allows multiple users to access the same network and no predestined path is needed. The disadvantage of applying packet switching is the protocols that are needed for the working of packet switching is very complex. There are often cases of loss of data packets during the transmission in case of overloading or corruption of data. With the increase in the data transactions over the network channel, have any of us ever wondered what procedures or protocols does the data must have to go through when transmitted over the network node? Well, this is what we will see in today's topic. Hi guys and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's video. For today's topic, firstly we'll understand what is an OSI model. Then we'll see the structure for the OSI model, continuing with knowing the layer structure and information in the OSI model. Let's start. To better understand the OSI model, let's take a look at a scenario. Assuming we have two different systems with different operating system installed in them, and there is a communication channel between them over which the data is shared. But sometimes during transmission of data, it faces some problems. These errors often arise due to the different operating system installed in the system or due to a network problem during a transmission. But to overcome such situations, the OSI model structure is used. Using the OSI model structure, we can make the transmission of data over the communication channel error-free. Let's take a look at the definition for the OSI model. The OSI model stands for Open System Interconnection Model, or a specifically designed set of protocols and standards that governs the modeling and conversion of the data for proper transmission over the network channels. The OSI model is based on the layer structure, where it consists of 7 different layers, where each layer has different set of protocols that are to be applied on the data during the transmission over the network channel. Let's take a look at the different layers of the OSI model. The OSI model consists of 7 different layers which perform specific functions and apply different protocols at different layers to maintain the quality and prevent the data from getting corrupted when it is transmitted over the communication channel. Let's take a look at each of them. The first layer is known as the application layer, which is the topmost layer. Then we have the presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, which is the last layer of the OSI model. The upper 4 layers in the OSI model represents the host layers. That is, they interact with the application related issues when the data is transmitted over the communication channel. Whereas the lower layers are termed as network layers. They specifically deal with the transmission related steps for the data over the network channel. Let's take a look about some information in regards to the layers. Now let's take a look at the function and the data format that is handled by each of the layers during the transmission of data. The first layer is the application layer, which interacts as a gateway for the host data and network applications and handles the data format. Then we have the presentation layer, which handles the initial step towards the conversation of data for transfer. It also handles the data format. Then we have the session layer. Session layer establishes a connection between the network devices for the data transfer. Then we have the transport layer, which oversees the data that is transferred without any error and is in the same pattern needed by the destination system. The data format handled by this layer is segment format. Next, we have the network layer, which determines the path for the data transfer. It handles packet-related data. Then we have the data link layer, which performs the task of connecting the physical nodes for the transfer of data. It handles frame data. And in the end, we have the physical layer, which is used to transfer the raw bits, that is, in terms of ones and zeros, over the physical mode. Now that we are clear about different layers that are present in the OSI model and some information regarding them, let's take a look at each of the layers in detail. We'll start with top to bottom. That is, the application layer will be the layer that we'll be starting with. Let's take a look. The topmost layer in the OSI model is the application layer, which acts as an interface between the user and the applications that are being accessed, which can be Internet Explorer, Chrome, or any email client. It also handles different protocols that are needed for the data transmission over the network channel, which can be given as Hypertext Transfer Protocol, the HTTP protocol, and the SMTP protocol, which is the Simple Mail Transfer Protocols. Now let's move on to the next layer. The next layer is known as the presentation layer. The presentation layer is responsible for performing conversion tasks over the data that is received from the application layer. The conversion of data is done in accordance to the required format. It also performs encryption over the converted data so as to prevent it from getting hacked by cybercriminals or hackers. The compression of the encrypted data is also performed by the presentation layer so that it can be passed on to the session layer. The next layer in the OSI model is known as the session layer. In this layer, the communication channel between two different devices is established. The network devices are individually known as session. The data that is transferred is to be done over these session channels. The layer that is the session layer establishes and terminates these sessions in case of an error or some other unforeseen event. This layer is also responsible for authentication checks regarding the data that is being transferred and also provides data recovery options in case an error occurs over the communication channel. As I model layers, let's take up a question. The question is, what is the main action that takes place at the presentation layer? And the options are, first option, data segmentation, second option, encryption of data, third option, framing of data, and the fourth option, bit conversion of data. You can provide your answers in the comment section below. Let's move on with the next layer. The next layer in the OSI model is known as the transport layer. The main task performed by this layer is to break the data that is received from the session layer into different segments. These segments comprises of protocols which are UDP protocol and TCP protocol along with the data that is segmented from the received data. Then the segmented data along with the UDP and TCP identification is transferred over to the transmission channel, where then it's further transferred to the network devices that requested for the data. This layer also performs a very crucial part, which is the flow control. Let's understand flow control over the network channel through a small example. In this example, the server has a capacity to send 50 Mbps of data at once, whereas the receiver side has a capacity for 10 Mbps. When the data is transferred from the server to the client, it transfers 50 Mbps. But it isn't possible to transfer all this data at once due to the lower capacity on the client side, which is why the flow control changes is required, which is provided to the server side by the transport layer. Now let's move on to the network layer, which is the third layer from the bottom in the OSI model. This layer is responsible for breaking down the segments into data packets by adding IP address to them that is received from the transport layer. These data packets are then further transmitted over to the best possible route to the destination system, which are governed by the Internet protocols, including IP and IPv6 protocols. For example, if we have a data that is to be transferred to the network device 2, we choose the best option, that is the route to be transferred over to that network device. Now let's move on to the next layer in the OSI model, which is a data link layer. This layer is responsible for maintaining and terminating the established connection between the devices over the network. The MAC address in this layer is added to the data packets, which are collectively known as data frames. These data frames are then further transmitted over to the physical network. These are divided into two different sublayers. Medium access control, that is MAC, which controls the established connection device. And the second sublayer is logical link control layer, LLC, which identifies the address and provides flow control for the data. This data frame, as earlier told, is transferred over to the physical layer. Now let's take a look at another question to brush up whatever we learned so far. The question is, which layer includes the MAC sublayer in the OSI model? Option 1, application layer. Option 2, session layer. Option 3, data link layer. Option 4, transport layer. You can give your answers in the comment section below. Let's move on to the last layer in the OSI model, which is a physical layer. This layer is responsible and provides the physical medium over which the data frame is transferred. But the transferred data is converted into bits before it's transferred. The transmission of data is covered by different protocols that are embedded in the physical layer. The transmission of ones and zeros format data is done. It also responsible for maintaining the data quality by applying different necessary protocols and maintaining the bit rate throughout the transfer of data, whether it be wired medium or wireless medium. In this session on User Datagram Protocol, we will look into the application of applying the UDP protocol and why it is used to transmit data in a network channel. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is the User Datagram Protocol. Continuing with knowing some features of the protocol. Moving on with header format of the protocol. Next, we will look into the working steps of the UDP protocol, applications of the UDP protocol, and in the end, we will look into UDP versus TCP protocol. Let's move on with the first heading, that is, what is User Datagram Protocol? The User Datagram Protocol, commonly known as UDP protocol, is designed to be unreliable and connectionless in nature, which applies process-to-process communication model for data exchange between devices and is active in the transport layer of the OSI model and is used to transfer data and information related to internet services over the network channel, where process-to-process communication refers to the use of port numbers in the header format during the transmission of data over the network channel. As for connectionless, it means that The UDP format does not provide a established path for the data to transfer. Instead, it uses multiple different paths, which we will look into further in the video. Let's move on to the next heading. Features of using User Datagram Protocol. The User Datagram Protocol provides the network with various efficient and easy to understand network protocol features to apply over the data that is to be transmitted. Where the first feature of UDP is related to the working area. That is, the UDP model is a transport layer protocol of the OSI model and is used to deliver best effort delivery options for the data transmission. Where the best delivery option refers that the protocol does not provide the sender will receive any acknowledgement from the receiver side for the data transmitted, or it does not provide any guarantee of data transmitted to the receiver side. Now let's move on to the second feature of User Datagram Protocol. The second feature represents the mode of delivery or connection that the UDP establishes for data transmission. The UDP protocol, as we know already, establishes a connectionless path. That means there's no actual virtual path for the data to be transmitted, so that each data from the UDP format uses a random path available in the network channel and reaches its destination. Now let's move on to the next heading, that is UDP header format. The UDP header format comprises of two parts. First, the UDP header part, which is 8 bytes in size, and second, the data to be transmitted. Furthermore, the header part is divided into four different parts: source port, destination port, total length, and checksum, where each of the parts are divided into 16 bits. Let's take a look at the different parts of the header format in a little detail. The first one is source port number. It is a 16-bit value that is used to identify the port that is transmitting the data. Next is destination port number. That is used to identify the port number that will be receiving the data on the receiver end. Next we have total length. As the name suggests, this value is used to specify the total length of the UDP packet, including the UDP header part. And the last is checksum. This is a 16-bit value field and is used as an optional attribute. It is left empty if there is no need, or it is used in case where accuracy of the data is to be measured. Now let's move on to the working of the UDP protocol. To begin with, we have data from the sender side, which is enclosed with the UDP header for communication and data in the UDP header part. The next step is to hand over this data over to the IP section for encapsulation, with the IP header and data with the UDP header and data part. As for the last step, this part is handed over to the frame section, where it is transformed with the frame header and data format. Moving on, now let's transmit the data over the network channel for the receiver end to receive it. Over to the receiver side, the first step is decoding of frame header part and data part into the IP section, which contains IP header and data section. Again, this IP packet is divided into UDP header part and data part, from where the message is retrieved from the data section of the UDP header format and is then received by the receiver end. Now let's move on to the applications of UDP protocol. Let's take a look at some of the features of the UDP protocol that provides applications to various network models. For the first one we have, it provides flow control and error control mechanisms to the network model, such as TFTP. Next, it provides faster transmission of data as there is no pre-established virtual path needed. So it is used for real-time services, live communication, and gaming services. Now let's move on to the last setting for this session, that is UDP versus TCP protocol. We will differentiate between UDP and TCP based on some attributes that are mostly used in a network model. And the first attribute is reliability. For UDP protocol, as we already know now, it is an unreliable in nature. That is, it does not provide any guarantee of data transmitted to the destination side is reached or not. As for TCP, it provides reliable and guaranteed data delivery to the receiver side. The next attribute is acknowledgement signal. The UDP protocol does not provide any acknowledgement from the receiver side to the sender side. Whereas in case of TCP protocol, sharing the acknowledgement signal is very important. If the acknowledgement signal is not shared by the receiver side to the sender side, the data exchange will halt. Let's move on to the next attribute, that is connection mode. As we already know now, UDP is a connectionless mode of service. There is no virtual path established for the data transmission to take place. Whereas for TCP protocol, it is a connection-oriented protocol. That is, a virtual path is needed for the data to be transmitted over to the receiver side or the destination node. The next attribute is error check system. In UDP protocol, basic check system is only used for error check. Whereas for TCP protocol, it is an extensive error check service. And along with error flow control mechanism included in the TCP protocol service. In a network channel, there are multiple devices at work that oversees the data exchange over the communication channel. These devices are differentiated based on their performance, processing unit, and working protocols, which we'll be discussing later in the session. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for this session. To begin with, we will look into what is a hub and some information related to the network hub. Moving to the next topic, we will look into what are network switches and some information about the same. Next, we will look into what are network routers and how they affect the networking exchange of data between communication channels. As for the last topic will be a difference between a network hub, switch, and a network router. Let's begin with the introduction to the network hub. A network hub is a device that is designed to connect multiple network units in a closely connected network channel. So hubs are also used in LAN networks. The network hub shares data with the destination device by acting as a central connection point of data transmission and connecting all the other devices in the channel. Some points to remember about the working of a hub. Hub is incapable of processing any complex protocols due to the absence of an intelligent unit in the system. Also, the physical model of the hub is composed of multiple sockets for connecting network devices. Now let's move on to the working of a network hub. For the first scenario, we will assume that a message is being sent through the hub to a destination node. Let's begin. According to the example, hub has received a message for device A, where it will share the same message to device A, which is a basic protocol. But due to the absence of any intelligent unit or a processing point in the hub device, it will share the message for A to all the other connected devices that are device B as well as device C. This creates a lot of access of traffic in the network channel. Now let's move on to the second scenario, which is when receiving a response from the device. In this case, when the device A shares a response to the hub to be sent to the sender device, it will share the same response to all the other connected devices, again due to the same reason, that is lack of any processing unit or intelligent point in the network channel. Please take a look at the arrow points, which is very important during the transmission of data. With this, we have cleared all the points that are important for a network hub. Now let's move on to the next topic, that is information on switches. The network switch is a networking device that is active in the data link layer of the OSI model and is designed specifically to connect private networks in a LAN channel. Switches are programmed to share messages only with a designated device that is mentioned in the header format of the message, which cuts down the network traffic in the channel. Switches uses different types of data, which can be either packets or data frames. Switch uses a destination source address and the destination address for forwarding the message to the specific device in the system. Now let's look into the working of a network switch. The first scenario is when the message is received to a switch and is to be forwarded to a particular device. In this case, we are receiving a message for device A, which will be shared only to device A according to the address mentioned in the header format. This decreases the network traffic in the channel and also prevent the access of message to device B and device C. This task of managing the address and sending the data to the designated device is handled using MAC address, which is used by the network card installed in the network device. Now let's move on to the second scenario, that is receiving a response from the device. In this case, the switch will receive a response from device A, which will be forwarded to the sender's address mentioned in the message. And this will prevent the response to be shared to device B and device C due to the presence of a processing unit in the switch. With this, we have completed all the important points to be known regarding a network switch. Now let's move on to the third topic, that is information on routers. Let's begin. A network router is a device that is designed to share data between multiple networks at a much larger scale in comparison to a hub or a network switch. It is connected to multiple devices at a very large level that can be considered as metropolitan area network or a wide area network. Router uses IP addresses to share data with the specified device in the network channel. And they also perform the task of translating an address that is available in a private network to a globally recognized network so that it can access internet, which is known as NAT, Network Address Translation. If you want to look further in the translation process that the router performs, you can visit our video on the same in the Simplilearn channel. Now, with this, we have completed all the introduction points regarding a network router. Now let's move on to the working of a network router. In this scenario, a message has been received by the router for device A, from which it will deduce the IP address for the device A and share the data. The message deliver efficiency is highest in case of a network router, as it uses routing path from a routing table to guide the message to its destination point, and vice versa. With this, we have completed all the important points regarding a network router. Now let's move on to the last heading for this session, that is difference between a network hub, switch, and a router. For this difference, we will use different features to differentiate the working of a hub, switch, and a router. The first difference is based upon the OSI model layer. In case of a hub, it is active in the physical layer of the OSI model, that is also known as the first layer. And in case of a switch, it is active in the data link layer of the OSI model, also known as the second layer. Whereas a network router is active in the network layer of the OSI model, also known as the third layer. Now let's move on to the next difference, that is based on addresses used by each of them. Let's take a look. A hub, as we already discussed, doesn't use a MAC address or an IP address for the transmission of data in the network channel. In case of a switch, it uses MAC addresses available in the network channel to provide a guidance system for the message to be transferred. Whereas in case of a router, it uses IP addresses to transmit the data to the designated device. Let's move on to some other differences, that is, format of data used in each of them. Hub uses electrical signals or bits for data transmission in a network channel, whereas switch uses a data frame or data packets for the transmission of data over the communication channel. And in case of a router, it uses data packets to be transferred. And the next difference is based on the mode of transmission. Let's take a look for this. A hub is based on half duplex network connection. That means at a certain point of time, only a single device can share or receive data from the other endpoint of the network channel. And in case of a switch, it is full duplex network connection. That means it can simultaneously receive and send a data packet or a data frame to any of the network devices connected in the system. Similarly, a router is also based upon the full duplex network connection form. Let's move on to the next difference, that is installation purpose. On the basis of installation purpose, a hub is mainly preferred in a LAN network or in a private network where 2 to 3 devices are to be connected, which increases the efficiency due to the absence of a processing unit in a hub. As for a switch, it connects multiple LAN networks or a large area network available. As for the case in a network router, it is a global network that connects multiple devices across the globe and is also designed to connect internet to any of the device. Let's take a look at the next difference, that is device classification. In case of a hub, it uses broadcast format or a broadcasting device to transmit data over the communication channel due to the absence of any processing unit in the system. And in case of a switch, it uses multicasting application for the transmission of data. And in case of a router, it uses routing path from a routing table to transmit the data in the communication channel. Let's take a look at a few more differences, that is installation cost. A network hub can be installed very easily in a network channel as it does not perform any complex task. In case of a switch, it required moderate cost installation as it performs some complex queries or complex protocols in the network channel. Whereas in case of a router, it is the most expensive to install in the network channel due to the high device specs and the performance-based protocol. And the next difference is based upon processing and intelligence. Now that we are clear, a hub device does not have any processing unit or intelligence point and is the most basic point of data transmission. Whereas in case of a switch, it possesses a processing unit to differentiate the destination address or a source address in the header format of the message. Whereas in case of a network router, it is the most sophisticated device among all the 3 network devices as it performs the most complex queries and protocols in the network channel. Distance vector routing. This is a protocol in data network that helps to determine the best route for data packets to travel in a network channel. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's video. In today's session, we will look into the introduction for distance vector routing, continuing with some key points for routing protocol. Moving on to distance vector routing algorithm. In the end, we will look into some examples to better understand the routing protocol. Now let's move on to the first heading for this session, that is Introduction to Distance Vector Routing. Distance vector routing refers to the distance or the vector that is between the neighboring nodes in a network channel, and the routing part refers to the established route through which data packets are transmitted in the network channel. The other aspect of this routing protocol in a network channel is to determine the shortest path for a data packet in the network to reach its destination. Next, we will look into some key points regarding the routing protocol. For routing protocol, three primary key points are to be remembered. First one being, each router in this protocol is designed to share the vector data of each node throughout the network. This step is done to maintain proper circulation of data in the network channel. The next key point is the routing pattern in the network protocol. That is, the data shared by the routers is transmitted only to those nodes that are directly linked to a particular router. The last key point is that the routing protocol is designed in a manner that it shares the updated vector data periodically at the network channel. Now let's move on to the next heading, that is the algorithm used in the protocol. The algorithm used in this protocol is termed as Bellman-Fold algorithm. This algorithm defines the shortest path that a data packet can take to reach its destination node from an initial node, where d of xy refers to the least distance from a node x to node y. Moving on, we have c of x comma v, where x's cost from each of its neighboring v node is taken into consideration. Then we have d of vy. This is the distance of each neighbor from its initial node. And lastly, min of v. This is an abbreviation used to determine the most shortest vector after the solution is obtained using the algorithm. In the next heading, that is network example, we will understand all the points used in the algorithm. Now let's design a network model with 5 different nodes that are A, B, C and D, with each node connected to each other using different network channels. The numerical values in the network channel refers to the vector count, that is the distance from node A to node B or to some other node in the network channel. In a network model, each node shares its vector data with its neighboring node at a regular interval, as there are various updates in the network model. This data is shared in a form of routing table, where three different columns are used. First being destination column, second vector column, that is the distance node, and lastly the hop. Let's take a look at the neighboring nodes for this model. For node A, we have B and E, as it is directly interlinked to the node A. For node B, we have node A and node C. For node C, we have B and D. For D, we have C and E. And lastly, for E, we have node A and node D. These nodes represent only the neighboring nodes. Now let's solve an actual example on routing protocol to clear all our doubts and understand the key points. The example we will be taking to solve is this network model. The initial step to start solving the network model using the distance vector routing protocol is to make a routing table for each of the nodes. Let's make the routing table for node A. This is the routing table for node A, where we have destination as A. That means destination is A from node A. That means the distance vector should be 0. Then we have destination as B. Let's take a look. In this given example, there is no given connection between A and B. That means this distance vector would be infinity. Then we have destination as C. Similarly as node B, there is no direct connection between A and node C. That means this is also infinity. And same is the case with node D. And in the end, we have node E, that is the only directly linked node to node A. That means the distance given is 5. So the network vector is 5. Let's make another routing table for node E. This is the routing table for node E. Let's take a look. In this routing table, the first is destination to node A. According to the network model given, distance is 5. So the vector value is 5 with the hop to A. Then we have destination as node B. According to the model, the distance vector should be 4. Then we have destination as node C. As given, there is no direct connection between node E and node C. That determines the value would be infinity. Then we have node D, which represents direct connection with node E, and the value is 7. And lastly, E destination from initial point E would be 0 vector. Now let's make another routing table similarly for node C. Now using the same steps, you can make the routing table for the remaining nodes, that is node B and node D. Now let's move on to the next step in solving the routing issue. This step is known as update step. In this step, we use the vector column from each of the node to update the vector column or the routing table for a particular node. In this part, we'll use node E's vector column to update the routing table for node A. And the steps are using the algorithm, that is the Bellman-Ford algorithm we used earlier. As we already know, moving from A to destination node A is always 0. So we won't be doing this step. Let's move on to the next one, that is moving from node A to node B. That would be A comma E, as we are using vector column of node E plus and the distance used to reach E from B. A comma E represents 5 and E to B represents 4 according to the network model. So the value is 9. Similarly, let's solve for A to C. To A to C we have A comma E plus destination required to move from E to C. According to the network model we have Node A is only directly linked with node E, so the value would be 5. But there is no connection between node E and node C, so the value would be infinity. Moving on, we have A to D. In this case, we have A comma E. The value would be 5 plus E to D, that is a direct connection, and the value would be 7. So the total distance is 12. And the last one is A to E. For this we have A comma E, that is directly the neighboring node. The value would be 5. So the new routing table for node A is 0, 9, infinity, 12 and 5. Similarly, let's take another node for this. For the next node, we will take node C and we will update the routing table of node C using its neighboring nodes, that are node B and node D according to the network model. Now, how to do this step? Firstly, it's C to destination A. In case of node B, we have C to A, that would be C comma B, that is a direct connection, plus distance required from B to A. According to the network model, we have C comma B as 6, plus B to A does not have any connection, that is infinity. So the value would be null. Then we have node D. In this case, we have C comma D, that is a direct connection, 3 plus D to A, that is again infinity, as it is not linked directly to node A. Moving on, we have destination as B. For node B, we have direct connection, so C comma B value is 6. Whereas for node D, we have C comma D, that is distance 3 plus D to B, that is infinity, as it is not directly linked with the node B. So again the value is null. Then we have destination as C. So connection between C to C is 0. Moving on, we have destination at node D. That would be C to D, as C to D, as there is no direct connection between node B and node D. So the value is infinity. Whereas for C to D is a direct connection for node D. So the value would be 3. Now for the last node, that is node E. In case of node B, we have C comma B plus B to E, where the value for C to B node is 6 and B to E is 4. So the sum is 10. And now in case of node D, we have 3 plus 7. That would be distance from C to D and then D to E. And the value would be again 10. So we can use any of the side to reach the destination node E. By completing all the steps, we have the new table for node C. Similarly, we can find the routing table for all the nodes present. Now, to look into some key points we learned. For the initial step, use only the node distance of immediate neighbors. Nodes without distance that is directly linked to each other is always infinity. For the update step, use the vector table of the only neighboring node we have for the initial node. And lastly, to continue the update step, roughly n-1 iterations are used, where the value of n is equal to the number of nodes. For example, the model we took had 5 nodes. That means we have to do a loop of 4 iterations.
Do you know, friends, that Wireshark is a powerful network protocol analyzer that helps you capture and analyze network traffic in real time? It allows you to deep dive into data packets traveling through your network, giving you insights into network performance, security, and troubleshooting. In this tutorial, we'll guide you through the basics of using Wireshark, from setting up your capture environment to interpreting the data. By the end of this tutorial, you will have a solid understanding of how to navigate Wireshark interface, set of filters, and analyze the network traffic for different use cases. So guys, let's get started. Let us start first by understanding what is Wireshark. So guys, Wireshark is a comprehensive open source network protocol analyzer that basically allows user to capture and analyze the data traveling over the network in real time. It is widely used by network administrators, security professionals, and also developers for various purposes. For example, guys, like network troubleshooting, where you have to identify and resolve network issues by examining the traffic patterns and diagnosing the connectivity problems. The next one is network analysis, which we'll also be doing in our hands-on, where you have to understand and optimize network performance by analyzing data flows and interaction between network systems. The third one is security auditing. You will also have to detect and investigate unusual or potentially malicious network activities such as unauthorized access or data breaches. And finally, you have a protocol development, where you can debug and develop network protocols by capturing and analyzing protocol messages and behaviors. The key features of Wireshark are: the first one is packet capture. Wireshark captures packets of data transmitted over the network. Each packet contains a wealth of information, including source and destination addresses. And also you get protocol, types, and payload data. So as you can see all over here, I've already downloaded Wireshark, and I'll guide you also how to download it. But as you can see, these are the lines that shows that the Wi-Fi packet graph is showing that this is how the packets are transmitting. So this is basically the real-time analysis what you can get through in Wireshark. Next one is you get a detailed inspection. Guys, Wireshark also decodes and displays data at various protocol layers. Example, you can get Ethernet, IP, TCP, HTTP, which allows for detailed examinations of network communications. You can also perform filtering and searching. Then you'll also get a chance to do data visualization, which includes features for visualizing network traffics such as flow graphs, as you can see all over here, and also statistics, which can help in understanding network behavior and performance. Wireshark is available for multi-operating systems, like for Windows, macOS, Linux, and many more. Now, there are certain scenarios where network security engineers use it. Suppose for network performance monitoring, where you track and analyze the performance of network applications and services. You also get an incident response. You investigate and respond to network security incidents by analyzing captured traffic. And you also do the protocol analysis, where you examine and troubleshoot network protocols and ensure proper implementation. Now, let us start with the Wireshark. So first, let us download the Wireshark. And before we download it, I expect that you would have got some brief idea regarding what is Wireshark. Now, what you have to do, guys, you have to go at this link, wireshark.org.download.html. So since I'm using Windows, so I have clicked on Windows x64 installer. Just right click on this. So as you can see, it will start downloading. So guys, since I've already downloaded it, I may not have to do it again. And the steps are very simple. Just you have to click yes, and it's going to download all the required dependencies, and your installer will be ready. And after clicking all the OKs, you are going to get something like this. So this is your entry of the Wireshark network analyzer. Now, so as you can see all over here, you can capture the network packets from these interfaces. So you can see local area connection 10, adapter lookup, traffic capture, Bluetooth is there. Then you have the Ethernets. Okay. So let us choose the Wi-Fi as a network interface. Okay. And just click on this. So as you can see all over here, so many of the packets have started running up. Okay. And this is a shark icon. So basically, it is doing the real-time packet capturing, where you have all these things. So now, let us try to understand what is there in Wireshark. So you can see you have file. Basically, for managing files, you have open, save, export. Okay, so these kind of options are there. You can also export the TLS session keys. Okay, you can export the objects, and you can do print, quit. Then here in the edit, so edit, you can modify the preferences, settings, and profiles. If you talk about view, you can adjust the layout all over here of Wireshark. If you talk about go, you can navigate through the packets all over here. Then here is a capture. You can start or stop all over here. You can restart it. Then next is analyze. So as you can see all over here, you have display filters, display filter macros, display filter expressions, and many more. Okay. Similarly, you have statistics, okay, which helps in viewing network statistics and data summaries. Here you have telephony for using these kind of protocols. Okay. Then you have wireless. Okay. Then you have tools all over here: firewall, ACL rules, MAC address. Okay. And there you have the help icon. So this is a very basic outview of this application. Now, let us do some basic exercises first. So let us try to capture a traffic first. Okay. So since I've already selected our network interface as Wi-Fi, and let us restart it. So you can just go on capture and just start the restart. Okay. So this has started. Now go to your browser and just type, say, HTTP. Okay. And say bin.org is the file. So guys, this is a basic website that we have requested on our browser. And let us go to our Wireshark and stop this for a moment. So as you can see all over here, this icon shows applying a display filter. Now go all over here and type the filter, say HTTP. Okay. And you can say our filtering would be done. So as you can see, here you have the source, you have the destination, here you have the time, here you have the number, here you have the length of the packets, okay, and this is the info, okay. So now let us do the general analysis of the Wireshark output. So as you can see all over here, the first one is HTTP request and responses. So as you can see, this is our source, okay. We are sending a request to the destination address with 44.219.81.240. The protocol is HTTP and the length of the packet is 480. And it is basically a GET request, okay. So get HTTP/1.1. Now there is a reply from this destination all over here and to the destination at our source. The protocol is still HTTP. Now the length of the packet is increased, is 887. And what we are getting, guys, all over here, that the status is 200 and it says okay. Now, as you can see, what we are getting basically an HTML file all over here. Okay. Now, similarly, we are again requesting and we are getting a JSON file all over here. Now, getting a specific JSON HTTP 1.1 and similarly reply is coming. So as you can see, it's a to and from motion where we are requesting to a destination, which is the browser with the protocol HTTP. And similarly, we are getting a reply from our destination. So guys, this is our device and this is the given resource we are trying to access on our browser. So basically, now we can see these are the content types, which is text HTML for the HTML structure. Okay. And also you can see all over here, this is a JSON type. Okay. And these are the type of the content we are trying to access it. Okay. And this is the request what we have done to our destination, which is the browser. Okay. With the bin.org, and it is returning a text.html file. I hope so guys, you would have got a brief idea like how you can do the general analysis of the Wireshark output. Now let us try to do one more example which will make our concepts more clear. Now guys, I will show you one more use case of this, that you can diagnose the network issues with ping and trace command. Okay, so with the help of Wireshark, this can also be done, guys. So what you need next is you can open a terminal, okay, and just right click all over here. And now in this, what we are going to do, guys, we are going to generate an ICMP traffic. So with the help of ping command. Okay, so now what we do, we type ping, say google.com. And you can see all over here, the request and reply have started. And now what we will do, guys, we will use the tracer command for tracing our packet flow. So you can see something we have got all over here. We will discuss about this bit later. Now let us open our Wireshark. Okay. And what we'll do, guys, we will type ICMP. Okay. And just click all over here. Okay. So guys, go to the filter and type ICMP. Okay. And just click all over here. And but before that, you have to stop this. And now let us try. So you can see all over here that here the destination is showing unreachable, but here we are getting the reply. Okay. Now let us try to examine this protocol. Okay. So what all over here, let us try to understand first what we did in the terminal. Okay. So guys, when we are typing the command ping google.com, this command is basically testing the reachability of google.com by sending the Internet Control Message Protocol or ICMP echo request packets and waiting for the replies, which is echo response. Now guys, let us break down the ping results. So first 3 replies, we are going to see that each reply shows the IP address of 142.250.193.110, which is one of the Google servers. And you can see the round trip time latency for the packets. For the first time, it is showing around 76 milliseconds. For second round trip time, it is showing around 88. Then third is 99, and fourth one is 30 milliseconds. Now you can see there is something called time to live also, and in this case the time to live for each packet is around 55 milliseconds. Okay, so basically this field indicates how many hops or routers the packet can pass through before being discarded. Okay, now you can also see the request timeout. So the fourth packet is a request timeout, meaning no reply was received within this set time. And you can also see the ping statistics. So you can say here sent 4 packets, received 4 packets, and there is no loss. Okay, so this is one thing. And also approximate round trip in milliseconds, you can see minimum is 30 milliseconds and maximum is 99 milliseconds. Average is calculated 73 milliseconds. So this is statistics what we got. Now you can see all over here we have the tracer command. Okay, so here no arguments are provided first. So let us try to understand. The D means do not resolve IP address to host names. Okay, where H means maximum number of hops of routers to search, and W means timeout in milliseconds for each reply. So suppose if I see tracer.google.com, so guys, this will show all the hops that the packet has to travel through reach the Google server, which will help to diagnose where the delays or issues might occur on the path. Now you can see all over here there are a lot of options are given. So similarly you can read this. Now let us try to do the Wireshark analysis. So you can see all over here with our source 10.101.5.118, and we are sending the request to the Google server, and this is Internet Control Message Protocol. So you can see all over here this is echo, this is a ping request with ID 0x001, and we can see the sequence is also given, the time to live, and we are replying in 7641 milliseconds. So this packet is basically what we are doing, guys. We are 7630 is our packet number, and this is what we are sending as a request. Then 7641 is a reply from the Google server with the given ID, okay, the sequence number of this and the time to live, and it is also giving the request one. Now what you can do, guys, you can also apply one filter all over here. We can, okay, now with the help of this you can just see there are a lot of options as a filtering. Okay, so you can read the documentation for this, and whenever it is turning red, guys, it is showing something as error. Okay, and now let us do this and let us type our IP address, say 101, okay, 1.5.118. Okay, so this is also one of the way you can apply the filter. Okay, so it's going to filter out the IP address. Okay, say let's do this. So it is going to filter out our IP address, which is basically the same which is sending, because we have not given any other ping request. So guys, here what we can see, so this is kind of the analysis what we are doing basically. Okay, so guys, this was a Wireshark analysis for diagnosing the network issues with the help of ping and trace commands. And you can do a lot more other things with the help of Wireshark. Basically, these tools are used by network administrators, hackers, and also network engineers to understand the network performance, diagnose the network issues. Okay, so this was a short exercise which I have shown you about the basics of Wireshark. I hope so you would have enjoyed our today's video. Welcome to today's video on network protocols. In this video, we are going to learn about the fundamental rules that allow devices to communicate seamlessly across a network. But instead of just listening to technical definition, we will also going to explain everything using a fun and relatable analogy. So guys, if you want to learn more about networking protocols, watch this video till the end. Imagine a city so technologically advanced where every building, vehicle, devices communicate seamlessly through a vast interconnected network. And the backbone of that city is the network protocols, which are set of predefined rules ensuring that all the devices, regardless of their make or operating system, can exchange data smoothly and securely. In this tutorial, we will explore the world of networking protocol, categorize them based on their functionality, and also dive deep into how they operate within the OSI model. So moving ahead, first, let's understand what is actually a protocol. So guys, protocol is a set of rules and standards that define how data is transmitted and received between devices in a network. It acts as a common language that enables computers, servers, and other devices to communicate effectively regardless of their differences in hardware or software architecture. For example, let us say, imagine you are making a phone call, okay, to a friend all over here, as you can see in this diagram. And you say hello to initiate the communication. Your friend responds by confirming that they can hear you. You speak in a language both of you can understand. You take turns in listening and speaking. When the conversation is over, you say goodbye and end the call. This is the structured way of communicating following a set of unwritten rules, a real-world example of a protocols. But if I talk about protocols in networking, they define how data is packaged, transmitted, received, and interpreted. They ensure that data is sent in a correct format, the receiving device understands and processes the data correctly, errors are detected and corrected if needed, security measures are in place to protect data from unauthorized access. Now, let us move ahead and understand about what are different types of networking protocols available. Now we are going to study about types of networking protocols. So network protocols can be broadly divided into three major categories. The first one is communication protocols. Here, these protocols ensure there is a seamless data exchange between devices. If I talk about security, then these protocols ensure that there is a secure communication against cyber threats. And finally, if I talk about management protocols, they monitor and optimize network performance. To understand these better, let us explore each one of them one by one. So if I talk about communication protocol, so this protocol governs data transmission and define structure, format, and method for exchanging messages between devices. So we have this HTTP protocol or hypertext transfer protocol. So this is a backbone of the internet and it facilitates the web exchange between a server and a browser. So this is one kind of a protocol. Then you have a TCP protocol, which is a transmission control protocol. So it is a connection-oriented protocol where protocol is ensured that the data packets are delivered accurately and they are in order. Then we have the Internet Protocol or IP protocol. These protocols addresses the system of internet, routes a packet across the given network. Then we have the UDP. So this is User Datagram Protocol. So it is a fast and connectionless protocol. And then you also have this File Transfer Protocol, which enables file sharing between servers using separate connections for controlling and data transfer. And finally, you could also see an ICMP, which is not mentioned in this diagram, so which is basically Internet Control Message Protocol. This protocol acts as a diagnostic tool, helping detect network errors and connectivity issues. So let us take an example and try to understand the communication protocol. Now, imagine you are sending a parcel from one city to the another, or you can also consider sending from one country to the another. Now, let us understand how these protocols are going to work. So if I talk about TCP IP that we have discussed earlier, you can consider it as a courier service. You choose a reliable courier company that ensures your package is delivered intact and it is in order. So the courier service, which is reliable, that is TCP IP protocol working all over here in this scenario. Now, if I talk about UDP or User Datagram Protocol, You can consider this as a public announcer. So instead of a courier, you broadcast a message over the city's public announcement system that everyone hears it. But there's no guarantee also that anyone will respond. Then you could understand FTP protocol as a parcel delivery system. So you use a secure delivery truck to send bulk packages from one place to the another. And if I talk about ICMP, so this is kind of a traffic reporter. This protocol is working like that. So this protocol service monitors traffic and alerts courier if certain routes are blocked. So in this way, these communication protocols are working. These communication protocols also ensure that fast, structured, and reliable delivery of data is happening in the digital network, just like cities' postal and transport system. Now let us move ahead and discuss about the security protocols. So if I talk about the network security protocols, so these security protocols protect sensitive data from unauthorized access, cyber attacks, and data breaches. Now if I talk about SFTP, which is not mentioned here, so you can consider it as a secure version of FTP, so which basically ensures the secure file transfer. So here it encrypts a file transfer using the public key encryption for authentication. Then you have the HTTPS, which is Hypertext Transfer Protocol. This is a secure version of HTTP which encrypts data between browsers and the servers. Then you have the SSL also, which is a secure socket layer, and it ensures that all the encrypted communication is happening over the internet, preventing any eavesdropping or any data theft. Now, as you can see also here we have the SMTP protocol, which is Simple Mail Transfer Protocol. It's also a communication protocol. So it is ensuring that it sends email over the internet, and also it ensures that emails are properly formatted, routed, and delivered to the recipient's email server. This protocol works in very simple steps. Like first of all, when you send an email, SMTP performs these steps. First is compose the email. Okay, so you type an email in your email client like Gmail or Outlook. Then it connects to a SMTP server when you hit send. So your email client communicates with an SMTP server. Then the routing happens in the email where SMTP server checks the recipient's domain name and contacts their email server. And then the email is being delivered. So the recipient's email server receives a message and stores it for retrieval. So these were one of the scenario. And you could consider the same analogy for SMTP as a postal system also. Now, suppose you write a letter all over here and you put it up in envelope. Okay, you drop it up at the post office, which is basically the SMTP server, where it's checked and it is sorted, and the postal system finds the recipient's address, mail server, and also the recipient can pick up and read the letter. Okay, so there are protocols like IMAP which are used to retrieve the emails. So SMTP only sends emails, not retrieves them. Okay, retrieval is done by IMAP protocol or POP3. So this was one of the example. Now let us discuss about SSH protocol. So SSH means it is a secure shell network protocol, which is basically used to securely access and control remote computers over an encrypted connection. It is widely used for securing remote logging and file transfers. Now, how does SSH works? So it initiates the connection. A user enters a command in the terminal, such as you can say SSH user remote server. Then the authentication happens where the user provides a password or uses an SSH key for authentication. Once it is authenticated, the user gains secure access to the remote server, and then the commands starts executing. The user can run commands, transfer files, or manage the system remotely. Imagine like a bank vault. Okay, so you can think SSH of a secure key card entry system for a high security vault. Okay, or in the banking, in the banks basically, where you will be needing credentials, password, or key card. Once inside, all the communications are private and encrypted. Okay, you can check records, retrieve documents, or make updates very much securely. And when done, you can log out and exit the vault safely. So you can think of SSH providing a secure way to access and manage remote computers, just like a bank vault system, which prevents the unauthorized entry. Now let us move ahead and discuss about our third and final protocol, which is basically the network management protocols. Network management refers to the process of monitoring, configuring, and maintaining the network devices to ensure a seamless communication is happening and preventing failures. It involves fault detection, performance optimization, and security enforcement. Now, the key network management protocols include like SNAP, which is Simple Network Management Protocol. So this protocol, as you can see all over here, this is basically used to monitor and manage network devices such as routers, switches, or servers. How this protocol works, guys? For example, devices have an SNMP agent that collects data, for example, the CPU usage or bandwidth. And the SNMP manager queries the agent to monitor network's health. If an issue occurs, then SNMP sends alerts called traps. So this is how it works. So for example, you can consider in a large office, SNMP alerts IT admins if a router is overloaded, something like this. Then we have the DHCP protocol, very famous protocol. So it stands for Dynamic Host Configuration Protocol. It automatically assigns IP addresses to devices in a network. So suppose when a new device connects, so it requests an IP address from the DHCP server. And the DHCP server assigns the available IP, preventing conflicts. This could be example in a Wi-Fi enabled office. Okay, so employee don't need to manually configure IPs. Here DHCP assigns them dynamically. Then we have the ICMP protocol, which is Internet Control Message Protocol. This protocol is basically used for error reporting and network diagnostics. Here ICMP actually sends a control messages like ping requests to test the connectivity. So if a network path is down, then ICMP informs the sender. For example, if a website isn't loading, then a technician runs ping www.com or any given domain to check if the server is reachable or not. Then we have the border gateway protocol. So this is kind of a routing protocol which determines the best path for internet traffic. Internet routers use BGP to exchange routing information mostly, and it finds most efficient route to send the data packets. For example, like in a fiber optic cable under the ocean, if it fails, then BGP reroutes the traffic via another path. Okay, so you can consider this example as how it is being used. Now we'll have a look on POP3. So POP3 means Post Office Protocol version 3. Basically, this protocol is one of the protocol that we have discussed earlier, that it retrieves email from the remote server. So when the user opens their email clients, POP3 downloads the messages to their devices. Emails are deleted from the server after retrieval. So for example, you can consider using an Outlook to download emails from Gmail server. Okay, so there it is used. Now, these protocols are very much important because they ensure network reliability by identifying issues before they cause any failure, optimize the performance by managing the bandwidth and traffic, and automate an IP allocation. And also, it ensures the security. So you could see this is as an example of network security protocol, how it's working. So suppose this is your office. Now the data packets are being sent. So here you have the IP header, then IP payload. So IPsec is a security protocol. So here the IPsec header is added and a secure payload is added, and the same is data is being transferred. This packet is to the laptop and it is routed via router IPsec. Okay, with IPsec protocol all over here to the branch office. So this is how you can consider architecture where the network security communication is happening. Now this is an example of a network monitoring protocol where there are endpoints. Okay, and these you could see you are sending the data about health and performance, and it aggregates data from multiple endpoints. The network monitoring tools are present which converts raw data into usable metrics, and then the following data is given to the network administrators. Also, it generates alerts and reports. So this is how the network monitoring protocols are working in this alignment. So we've discussed about these protocols, and this was a certain diagrammatic explanation. So I hope so you would have got a brief idea regarding these protocols. Okay. So now let us briefly understand the 7 layers of the OSI model. Okay. Now this is OSI stands for Open System Interconnection Model. So there are 7 layers in this model. Okay. And along with there are protocols also mentioned and the components associated with each layer. So let us break down these layers. So first of all, we have the physical layer. Okay. The purpose of this layer is to define the physical structure of the network, such as cables, switches, and wireless transmission. Here, the function is that of this layer is that it converts data into electrical signals like radio or optic signals for transformation. It also manages bit rate control and transmission media. Now, this is all about the physical layer. Then you have the data link layer, or you could say the error detection layer. This layer basically manages the direct node-to-node data transfer and error detection. The function of this layer is that it ensures that the data is correctly framed before transmission. It detects and corrects errors in transmission, and it basically uses MAC address for device identification. Examples of this layer could be considered as Ethernet or PPP, point-to-point protocol, switches, bridges. All these come into this layer. The third one, we have the network protocol or the routing layer. So this layer determines the best path for data to travel between different networks. It assigns logical IP addresses, routes data using protocols. It manages network congestion and fragmentation. The examples of this protocol could be IP protocol, ICMP, IPsec, IGMP, okay, Internet Group Management Protocols. Just like navigation systems, that determine the best route for a vehicles to reach destination. Similarly, this layer is working like that. Then we have the transport layer, which basically is like a delivery layer. It ensures complete and reliable data transmission. This layer divides data into smaller segments and ensures proper reassembly. It provides error detection and correction. It uses TCP for reliable transmission and UDP for faster connectionless communications. Examples could be, the TCP protocol or UDP protocol. So you can consider it like a couriers, that ensure that packages are delivered safely and in the correct order. So after this, the data is moved to the session layer, which is like the connection layer. It establishes, maintains, and terminates the communication sessions. It helps in managing sessions between applications. It handles authentication and any reconnections if needed. So for example, we have the API sockets all over here in this layer. So just like customer service representatives who handle call and ensure smooth communication between businesses, this layer is working like that. Then we have the presentation layer, which ensures that data is formatted properly for the application layer. It translates data formats like converts images, compresses file, encrypts and decrypts data for security. Then we have example of presentation layer like SSL, Secure Socket Layer, SSH, IMAP protocol, FTP. So you can consider these as a language translators who convert a message into a format that the recipient can understand. And finally, we have the application layer, which has a purpose of providing network services directly to the users. It manages data exchange between applications and the network. It enables browsing, email, and file transfer. So example of this layer include HTTP protocol, FTP, IRC, SSH, DNS. Okay, so you can consider something like this as these are the customer-facing employee in a company who directly interact with the users.
Hello everyone, welcome back to Simplilearn's YouTube channel. Today, we are diving into a super important topic that affects everyone, phishing attacks. As cyber criminals get more sophisticated, it's important for us to stay one step ahead. So in this video, I'll be walking you through what phishing is, how it works, some famous examples of phishing attacks, different types of phishing, how to protect yourself, and what to do if you ever fall victim. So let's jump right in. What is phishing? To start, let's talk about what a phishing attack really is. In simple terms, phishing is a type of scam where hackers pretend to be legitimate people or companies to steal your personal information, whether it's your passwords, bank details, or even social security number. They typically do this through emails, text messages, or fake websites that seem genuine at first glance. But phishing attacks don't just rely on fake emails. They use a psychological trick known as social engineering. Now, social engineering is all about manipulating people into making poor decisions, like clicking on a malicious link or sharing personal information. Let's take an example. Imagine you work in a company and one day you get an urgent email from someone who looks like your boss. The email says, "I'm in a meeting right now, but I need you to send me the financial reports immediately. Click here to access a secure file." Because it's your boss and the message sounds urgent, you might not think twice and click the link. But that's where the trick is. The link wasn't real, and now the hacker has the access to the company's sensitive data. So social engineering works because it plays on human emotions like fear, urgency, trust, and leads you to make hasty decisions without double checking. So phishing attacks are serious business, and they have caused some of the most damaging data breaches in history. Let's take a look at some of the most famous examples. First, let's talk about the Sony Pictures hack in 2014. This is one of the most well-known phishing incidents. It all started when Sony employees received phishing emails that looked completely legitimate. Some employees clicked on the links in these emails, which gave hackers access to Sony's internal network. And the result? Over 100 terabytes of data were stolen, including unreleased movies, confidential employee information, and thousands of internal emails. The leaked data caused major damage to Sony's reputation and led to lawsuits. It was one of the most costly cyber attacks of its time. Another incredible phishing incident involved both Facebook and Google. Between 2013 and 2015, a single hacker managed to scam these tech giants out of over $100 million. How did he do it? The hacker, Evaldus, pretended to be a hardware supplier that both companies did business with. He sent phishing emails with fake invoices that looked exactly like the real thing. Because the emails were so convincing, the finance departments of the Facebook and Google didn't question them and wired the money directly to the attacker's account. So these famous examples show that phishing can affect anyone, from everyday people to major corporations. So let's talk about how they work step by step when hackers actually try to steal your information. So how does a phishing attack unfold? Let's break it into easy steps. Step 1. Phishing attacks typically start with a carefully crafted message, often in the form of an email or text. This message will look like it's from a legitimate company, like your bank, a popular service like PayPal, or even someone you personally know. Hackers usually use several techniques to make these emails look authentic. One common technique is domain spoofing. This is when hackers create a domain that looks almost identical to the legitimate website, but with subtle differences. For example, instead of paypal.com, they might use paypal1.com or pay-pal.com. Because most people glance at the sender's email address quickly, they don't notice the subtle change. The next step is to get the victim to visit a fake website. When you click on the link in the phishing email, you're often redirected to a website that looks exactly like the real thing. These fake websites are often designed to perfectly mimic the official login pages of services like your bank or email provider. To create these fake websites, hackers often use what's called a phishing kit. Now, phishing kits are pre-built tools that make it easy for attackers to clone real websites. The hacker then hosts the fake website on a malicious server or uses DNS spoofing, where they manipulate the DNS records to redirect users from the legitimate website to their fake version without the victim knowing. Now, once you land on the fake website, the next step is for the hacker to collect your information. So these fake pages are designed to look identical to the real ones. So when you enter your username and password, you think you're logging in securely. But hear what's happening in the background. Phishing sites use various methods to capture the information you type in. One common technique is form jacking, where the form on the website is modified to send the data directly to the attacker's server. Alternately, hackers can use key logging malware that records every keystroke you make, capturing usernames, passwords, and even credit card information as you type. So to make the fake site even more convincing, attackers often secure it with a real SSL certificate. Now, this means the website might show up as secure with a padlock symbol in your browser, making you believe it's legitimate. So this is why it's important to check more than just the HTTPS in the URL. Now, once the hacker has your data, they can use it in various ways. The most common method is using your stolen credentials to log into your accounts. This is known as credential stuffing. But they can also use your personal information for identity theft, or they might sell your data on the dark web. But phishing isn't a one-size-fits-all approach. Hackers use several different types of phishing attacks, and each one is designed for a specific target or method. So now let's talk about the different types of phishing attacks. First, we have general phishing, which is the most common and broad type. So in this type of attack, hackers send out thousands or even millions of phishing emails to random people, hoping that a small percentage will fall for the scam. For example, let's say you receive an email that looks like it's from a popular company like Netflix. The email says something like, your payment method has failed, click here to update your information. You click the link and it takes you to a fake Netflix login. When you enter your details, they are sent straight to the hacker. These attacks are sent out to as many people as possible. Whoever falls for it, falls for it. It's all about volume with general phishing. Next is spear phishing. So unlike general phishing, spear phishing is much more targeted. So the attacker picks a specific individual or company and tailors the attack to that person or group. So spear phishing requires some research and planning. So it's more sophisticated than general phishing. For example, imagine you work in the finance department of a company and you receive an email from someone pretending to be the CEO. The email says he's unable to transfer the money to the partner company and asks you to transfer it. So since it appears to be from your boss and it sounds urgent, you might be tempted to complete the transfer without questioning it. That's the goal of spear phishing. Because the email is personalized and often uses real names or insider informations, it's much easier to fall for it. So this makes spear phishing especially dangerous for businesses. Now let's talk about whaling, which is similar to spear phishing but with a bigger target. So whaling specifically targets high-ranking individuals like CEOs, CFOs, or other executives. So these attacks are often highly sophisticated because the stakes are so high. Let's say a hacker sends an email to the CFO of a large corporation, pretending to be a lawyer representing the company. So the email contains a fake warrant, asking the CFO to click a link to download important legal documents. Because it's a legal matter and appears highly official, the CFO clicks the link, which leads to malware being installed on the company's network. So whaling attacks are dangerous because they often involve larger sums of money or more sensitive information. So when high-level executives fall for these scams, the consequences can be disastrous. Next comes SEO phishing. So SEO phishing takes a different approach. So instead of targeting individuals with emails or text messages, hackers create fake websites and manipulate search engines so that these sites show up at the top of search results. So people who are searching for services or products may unknowingly click on these malicious websites. For example, imagine you are trying to log into Bank of America and you search for Bank of America login. So a phishing site could show up at the top of the result, looking exactly like the original website. You fill out the form, entering your personal and payment information. But instead of going to the bank, all of that information goes straight to the hacker. So SEO phishing works because we trust search engines to lead us to legitimate sites. Hackers take advantage of that trust by manipulating search engine algorithms to display their malicious sites. And finally, there's smishing, which stands for SMS phishing. Smishing involves sending fraudulent messages through SMS or text. So these texts often appear to come from a trusted source, like your bank or a delivery service, and contain a link that leads to a phishing site. For example, let's say you get a text that looks like it's from a delivery company such as FedEx, telling you to set your delivery preferences. The message includes a link to do the same. When you click the link, it takes you to a fake FedEx site that asks for your name, address, and credit card information to cover delivery fees. So smishing is effective because people tend to trust text messages more than emails, especially when they're on the go and may not scrutinize the message as closely. Anyways, fortunately, there are several things you can do to protect yourself from phishing attacks. So first and foremost, always think before you click. If you get an email or text asking you to click a link, stop and think. Does this look suspicious? Hover over the link to see where it actually leads before you click. Next, don't upload personal information online. Be careful where you share your personal information online. Hackers often gather details from social media or public profiles to make their phishing attempts more convincing. So make sure to keep your software, operating system, and apps updated. Regular updates include security patches that protect against known vulnerabilities. Next is use antivirus and email security. Install a good antivirus program and use email services with phishing filters. These tools can block many phishing emails before they even reach your inbox. And lastly, use a secure DNS service. This can prevent you from even accessing malicious websites, adding an extra layer of protection. Now, even with these precautions, phishing attacks can sometimes be successful. So what happens if you're already fallen a victim? Let's talk about what to do after a phishing attack. So if you realize you have fallen for a phishing attack, don't panic. There are steps you can take to minimize the damage. First, report the attack to cybercrime authorities. In many countries, there are dedicated teams that handle online fraud, and the faster they are notified, the better. Next, change the passwords for any accounts that may have been compromised. Make sure each password is unique and avoid using the same password for multiple accounts. Next, enable multi-factor authentication on your accounts. MFA adds an extra step, like a code sent to your phone, which makes it harder for hackers to gain access. And lastly, run a full malware scan on your devices. If you clicked a link or downloaded something from the phishing attack, malware might have been installed. So it's important to remove it as quickly as possible. And there you have it. We have covered everything you need to know about phishing attacks, from how they work, the different types, to some real-life examples of phishing disasters, and most importantly, how you can protect yourself.
Computer networks are often differentiated based on the mode of connection, like wired or wireless. They are categorized into different types depending upon the requirement of the network channel. For example, on the basis of geographical location and the data to be transmitted. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to miss an update from us. Now without further ado, let's take a look at the agenda for this session. To begin with, we will look at what is computer networks. Moving forward with different types of computer networks available in a network channel. Then we will look into one of the most used network channel, that is LAN network. Then MAN network. As for the end, we will look into WAN network. Let's move forward with the first heading, that is, what is a computer network? A computer network refers to a group of networking devices, for example, computer system, switch, router or hubs, connected to each other through a central unit to share hardware resources and information services. The mode to connect different devices in a computer network can be based on wired or wireless medium, which depends upon the requirement of the user and the availability of network channels. Now let's move forward with the next heading, that is different types of computer networks available in a network channel. There are different types of computer networks available to choose from, which also depends upon the need of the user or the network channel. On this basis, we can differentiate into 4 different types, where the first is personal area network, that is PAN, which, as the name suggests, is used in personal area to connect devices like mobile phones, personal computers, etc. The next type of network is local area network, also known as LAN. This area network is used to connect multiple devices across different buildings or multiple devices in a single building. And the next computer network is Metropolitan Area Network, also known as MAN, which connects multiple LAN networks within it. As for the last network, we have Wide Area Network, also known as WAN, which covers locations that are not easily available through wired medium. For example, different parts of states are connected to each other using wide area network. In this session, we will look into local area network, metropolitan area network, and wide area network. Let's move forward with the first, that is local area network. The local area network or LAN is used to connect devices that are available in a limited range or small geographical location, as it does not cover large locations because of hardware limitation. The devices that are connected in this computer channel use multiple protocols for proper and efficient exchange of data and internet services. The data exchange occurs from a server device that acts as a central unit and is passed on to the devices that are connected in the network channel. Let's take a look at some of the features of local area network. The data transmitted in the network, that is LAN network, is relatively higher in comparison to other network types, MAN and WAN, because it covers a small geographical distance, so the speed of data transmission is very high. LAN uses private network addresses for network connectivity, as the exchange of data and services takes place in a closely lit channel, which decreases the error occurring rate and also provides much better security. Let's take a look at some of the advantages and disadvantages of applying LAN network. For advantages we have, it has a single control unit which is used to store data and information and can be used anytime. Transferring of data and information becomes much easier and much faster in LAN networks. As for disadvantages we have, data security is compromised if the LAN admin decides to steal data and information. As for the other disadvantages, it requires constant administration for continuing data services and distributing hardware resources in a LAN network. With this, we have completed the LAN network part. Let's move on to the next, that is MAN network. The Metropolitan Area Network, or MAN, is a network type that encompasses network connection of an entire city or connection of a small area in a country. The area covered is less in comparison to WAN and faces moderate network traffic due to the large location it covers. The exchange of data occurs from one LAN network to the other LAN network, and this case is looped. Let's take a look at some of the features for Metropolitan Area Network. The Metropolitan Area Network covers a large geographical area and is also used as an internet service provider by many of the local services because it provides high data transmission rate. It also applies many network devices for smooth data services and is connected through telephone lines using wired medium to provide high internet services. Let's move on to the advantages and disadvantages of using MAN. It applies fiber optic cable for high transmission and much better security in comparison to LAN network. It also uses full duplex method for data transmission, that is, data exchange occurs simultaneously. As for disadvantages we have, it needs a good quality hardware resources and the cost of installation is very high. It also needs an experienced technician to maintain and provide much efficient data services in case of MAN network. Now let's move on to the next heading, that is WAN network. The Wide Area Network, or WAN, is designed to connect devices over large distances, like a global network, that is the internet. Because the Wide Area Network covers a very large geographical area, for example, connection between different states or even between countries. It uses wireless medium as a connection mode, for example, network towers and satellites. It also can be termed as the connection of multiple LANs or multiple MANs. Let's take a look at some of the features of Wide Area Network. Wide Area Network uses satellite medium, as we already saw. The satellite medium is used to connect multiple network towers, which in turn provide high-speed data connection for the devices in a network channel. Whereas the data transmission rate of a wide area network is in comparison to LAN and MAN very low because it uses wireless medium in most of the cases. So the speed of data transmission is low. And it also covers a larger distance, so it often faces data errors and loss of information. Now let's take a look at the advantages and disadvantages of applying WAN network. WAN network uses multiple network towers to connect numerous devices to be interconnected with the internet. It also covers a very large area to establish multiple connection between different parts of a country and also connect different countries as well. Let's take a look at the disadvantages of applying WAN network. The chances of an error occurring in a WAN network is very high due to the availability of different types of network channels, network devices, and different modes of connection medium. The initial cost of setting up a WAN network is very high, as it needs very experienced technician to work on and requires hardware resources, example satellites, network towers, which are very costly to set up. With the increase in data transmission and exchange between multiple network devices for information purposes, the probability of an error or damage occurring to the original data bit is highly possible. To overcome this situation, we use certain networking techniques to detect and correct the damage to the data, one of which we will be discussing in today's session. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is Hamming code. Then we will look into terms related to the Hamming code. And in the end, we will look at a working example of Hamming code. Let's begin. The Hamming code method is a network technique that is designed to detect errors and corrects data bits which are transmitted during data exchange. It was first implemented by R.W. Hamming, hence the name Hamming code. This network technique is implemented because during data transmission, there are often cases where data loss or data damage occurs. To recover or detect the damage in the original data, we use Hamming code. In the next slide, we will look into some terms that are related to the working of Hamming code. The first one being redundant bits. These are the extra binary bits that are added explicitly to the original data bit to prevent damage to the transmitted data and also to recover the original data in case of a damage at the receiver end. In the next point, we will look into some formula related to redundant bits and how to add them in the Hamming code. The formula related to redundant bits is 2r more than equal to m plus r plus 1, where m refers to the data bits in the data and r refers to the redundant bits. Let's take an example. In case m is equal to 4, that means the data bits used are 4, we need to find the value of r. Using the above formula, let's deduce the value of redundant bits. 2r is more than equal to 4 plus r plus 1. 2 to the power r is more than equal to r plus 5. So using this, let's use r equal to 0. If we use that, we will get a value 1 that is more than equal to r plus 5, but that is wrong. Then using r equal to 3, that is 8 is more than equal to 8. This way, we conclude that the Hamming code would be 7-bit data because the value of r is 3 and m is 4. Now let's move on to the next term related to Hamming code, that is parity bits. The parity bit is a method to append binary bits to secure that the total number of counts of 1 in the original data is either even number or an odd number. Let's take a look, why do we exactly use parity bits? They are used to detect error in the original data which occurs during the transmission of data. Through this method, we can detect the error at the receiver end and also correct it. Let's take a look at different types of parity bits available. First one is even parity bit. In this case of parity type, the total number of ones counted is to be even in the count. In case the count is odd, then the value of parity is 1. Otherwise, the value should be 0. Similarly, the other parity bit is known as odd parity bit. For this parity bit, the total number of ones counted in the original data should be odd. If that is the case, the value of parity bit should be 0. And in case the value of ones in the original data comes out to be odd, then the parity value would be 1. Now let's move on to the next setting, that is the working example of the Hamming code. Let's take a look. Let's begin with the steps to be followed to solve a Hamming code issue. The first point being, the position of the parity bit is determined using 2 to the power n term, where n represents the number series 0 to n. Assigning the position for parity bit using this method would be more clear during an example. For the second point, we have the remaining positions represents the data bit. Now let's try using the value of parity bit for n is equal to 0. That means 2 to the power 0 is equal to 1. So all the bits with 1 in the last position are used to determine the value of the parity bit. To better understand the assignment value of parity bit, please focus on this mentioned table. In this table, we can take a look at the last position, that is n is equal to 0, and see the mentioned number. For P1, we can use a value 1 because n is equal to 0 and the last position value is 1. Then is number 3 because the last position bit is 1. Then similarly for number 5 because n is equal to 0 and the bit value is 1. So these three parity value can be used for n is equal to 0. Similarly, let's take a look when the n is equal to 1. That means 2 to the power 1 is equal to 2. So all the bits with 1 in the second position are used to determine the value of parity bit. Now let's take a look at the table to identify the numbers related to this parity bit value. The first one being 2 due to the presence of 1 bit in the second position. Then we have P3, presence of 1 bit in the second position. Similarly, the next would be number 6 due to the presence of 1 bit in the second position. Similarly, let's take a look at when n is equal to 2. That means 2 to the power 2 is equal to 4. So all the bits with 1 in the third position are used to determine the value of parity bit. And this would be 4, 5 and 6 number. Please read the points very carefully because next we will solve an example to better clarify all the concepts. Let's move on. The given example is the data bit to be transmitted is 1011 and we have to solve this using the Hamming code method. So the first step would be applying the Hamming code method and identify the given number of data bits. That would be 4 according to the question. So the number of parity bit would be 3, where the value would be 1, 2 and 4 according to the power of P expression. That means we will get something similar to this. This representation is in data bits format, where the first position is for P1 parity bit, the second for 2 to the power 1, that is 2 P2, and the third one is for 2 to the power 4, that is P4 parity. And let's put the value that is to be transmitted in the remaining positions. That would be P1, P2, 1, P4, 1, 0 and 1. Using this bit value, we will deduce the value of P1, P2 and P4 for data transmission. In this case, we are using even parity for the example. That means the number of ones should be even. Let's take a look. For P1 we have D1, D3, D5 and D7 as mentioned in the earlier slide. So the value would be P1, 1, 1 and 1 according to the data bits available to us by the question. That means the value would be 1 because the number of ones for P1 is odd. So to make it even, the value of P1 would be 1. Similarly, for P2 we have D2, D3, D6 and D7. Using the same method, we will get P2, 1, 0, 1. So the number of ones for P2 is even. So the P2 value would be 0. Next is for P4. The value is D4, D5, D6 and D7, where P4 has 1, 0 and 1. That means the number of ones is even. So again P4 is equal to 0. Now using this, we get the new bit that is to be transmitted. That is 1010101. After transmission, in case, let's say at position 5 an error occurs and the value of 1 is converted to 0. To detect this error at the receiver side, we will use the Hamming code. To begin with, we will use the parity value to cross-check the original data bit. That means, let's do the parity bit method for this received data. So for P1 we have D1, D3, D5 and D7. So the number of ones is odd. That means the value of P1 should be 1 to make it even. Then for P2 we have D2, D3, D6 and D7. So the number of ones is even. That means the P2 value would be 0. Now let's move on for P4. That would be 4, D5, D6 and D7. Number of ones is 1. That means odd. So the value of P4 would be 1. Now let's take a look at the results that we obtained using this method. Foremost, this shows that the data transmitted is damaged and we can detect the error position using this method, that is, using the value of parity bits obtained, where this will lead to 2 to the power expression. That means 2 to the power 0 plus 0 plus 2 to the power 2. That means 5. That matches with the assumption we took. Now, to correct this error, we can use the position that we obtained, that is 5, and replace the 0th value with 1 bit. By doing this, we will obtain the original data. With the increase in the networking devices, either for professional or personal use, the need to access the internet to perform various activities has increased. And in this process, having an IP address assigned and then being routed to the network model and is applied using the classless interdomain routing CIDR. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is CIDR, that is classless interdomain routing. Moving on, we will look at some of the rules to perform the CIDR addressing, continuing with the working of the CIDR, and at the end, we will look into some examples to better clarify all the doubts we have learned so far. Now, let's take a look at the first heading, that is, what is CIDR? The CIDR, or classless interdomain routing, is a network concept designed to oversee the assignment of IP addresses to a system to replace the outdated way of classful addressing system. Furthermore, using the CIDR method, there is low wastage of IP addresses, and it also is helpful in maintaining the routing table, and it performs the task of subnetting, which saves a lot of IP addresses. Now let's move on to the next heading, that is rules of using CIDR. To better understand the working of CIDR addressing in the later part, please take a look at the rules very seriously. Let's take a look at the first rule, that is, the IP addresses assigned are according to the CIDR are to be continuous, as the ISP will provide them in a sequence to minimize the address wastage. For example, if we have an IP address 200.10.18.32, then the addressing will take place as 200.10.18.33 and moving on to the nth position, as mentioned in the example. This proves that they are continuous in assigning of IP addresses. Let's move on to the next rule, that is, the number of addresses in a CIDR block is to be power of 2. That is, in case the number of addresses is odd, then it's invalid value. For example, 2 to the power 4 is equal to 16, where 4 represents the number of hosts. Whereas, if the value is 17, then it's an invalid value. As for the last rule we have, use of CIDR block for notation purpose. That is, for example, if we have 200.11.19.34/28 as an IP address, then the block ID of this IP address is 28 and the host ID is 4, which is calculated using 32 minus 28, because in an IP4 address 32-bit is the maximum limit. Now let's move on to the next heading, that is working of CIDR. The CIDR addressing applies the variable length subnetting masking, that is VSLM for short, as the basis of its working method. That is used to break the conventional IP addresses into smaller subnetworks of varying sizes according to the user requirement. Let's take a look at an example to understand the working process. In the given example, the IP address is 195.10.20.40/16. Now let's solve the question. To begin with, from the given IP address, we can determine the network prefix. That would be 195.10.20.40, whereas the suffix represents the /16 part. The number 16 in an IP address represents the number of ones in the address. That is known as the block ID or the network ID. And the host ID is determined using 32 minus 16, because 32 is the maximum limit of bit length in an IPv4 address. So the host ID is 16. And the total number of hosts that are available in the network is calculated using 2 to the power number of hosts. That would be 2 to the power 16 for this case. So the value is 65,536 available hosts in this given network ID. Now let's move on to the examples to better understand the working. The first example is the given IP address 192.168.200.10/28, and we have to find the relevant information. Let's begin. For the first step, convert the IP address in a binary decimal format. That is, for this IP address, it would be the given binary format. Now let's find out the network mask for this IP address. That would be 28 ones and 4 zeros. The point to be noted is, according to the slash number, we point the number of ones for network mask. For example, in this question we have /28, so the network mask has 28 ones beginning from left to right, and the last 4 digits would be 0. And in numerical form, the value comes out to be 255.255.255.240, and this is the network mask for our IP address. Now let's move on to the next information, that is network ID. The network ID for the given IP address is calculated using this way. By the given subnet mask, that is /28, we assume that 192.168.200 does not change because it is a part of network ID. And the point to be noted is the network ID is never to be tampered with. Only the host ID can be used to change the value. That means we will open the .10 part in binary format. That would come out to be 000 1010. Then change ones to zeros and perform the AND operation. After performing the AND operation for the last 4 digits, that is the host ID part, we will get 192.168.200.0/28. That represents the network ID for the given IP address. Similarly, we can find the number of hosts. That would be easy. That is 32 minus 28, that is 4. And the total number of hosts would be 2 to the power 4, that is 16. And the first host ID in this given IP address would be 192.168.200.1. With the completion of this example, we have completed all the relevant parts regarding CIDR working.
The world runs on data now. The internet houses a treasure trove of potentially harmful information, from basic shopping habits to private financial transactions. All this data is carried over a network of interconnected devices. During transit, the data is as secure as the mechanism responsible for its transmission. It's in this phase that the most corrupted data originates. It's paramount that the networks carrying this data must be secured against malicious hackers and harmful attacks. Let's take a look at the topics to be covered in this video on network security, which is rising in popularity and importance. We start by introducing the viewers to network security and its basic definition. We cover the working of network security in the next section. Then we have the different types of network security, followed by a small introduction to transport and application layer security and the importance. Next, we cover the key tools in network security, the benefits, and a live demonstration of how Nmap can scan hosts and aid in ethical hacking. So let's start with the first topic for the day, which is an introduction to network security. Network security is a set of technologies that protects the usability and integrity of a company's infrastructure by preventing the entry or proliferation within a network. Its architecture comprises of tools that protect the network itself and the applications that run over it. Effective network security strategies employ multiple lines of defense that are scalable and automated. Each defensive layer here enforces a set of security policies which are determined by the administrator beforehand. This aims at securing the confidentiality and accessibility of the data and the network. Every company or organization that handles a large amount of data has a degree of solutions against many cyber threats. The most basic example of network security is password protection. It has the network the user chooses. So recently, network security has become the central topic of cybersecurity, with many organizations involving applications from people with skills in this area. It is crucial for both personal and professional networks. Most houses with high-speed internet have one or more wireless routers, which can be vulnerable to attacks if they are not adequately secured. Data loss, theft, and sabotage risk may be decreased with the usage of a strong network security system. Your workstations are protected from hazardous spyware thanks to network security. Additionally, it guarantees the security of the data which is being shared over a network. By dividing information into various sections, encrypting these portions, and transferring them over separate pathways, network security infrastructure offers multiple levels of protection to thwart man-in-the-middle attacks, preventing situations like eavesdropping, among other harmful attacks. It is becoming increasingly difficult in today's hyper-connected environment as more corporate applications migrate to both public and private clouds. Additionally, modern applications are also frequently virtualized and dispersed across several locations, some outside the physical control of the IT team. Network traffic and infrastructure must be protected in these cases since assaults on businesses are increasing every single day. We now understood the basics of network security, but we need to understand how network security works in the next section in slightly more detail. Network security revolves around two processes: authentication and authorization. The first process, which is authentication, is similar to access cards, which ensure that only those who have the right to enter a building. In other words, authentication checks and verifies that it is indeed the user belonging to the network who is trying to access or enter it, thereby preventing unauthorized intrusions. Next comes authorization. This process decides the level of access provided to the recently authenticated user. For example, the network admin needs access to the entire network, whereas those working within it probably need access to only certain areas within the network. Based on the network user's role, the process of determining the level of access or permission level is known as authorization. Today's network architecture is complex and faces a threat environment that is always changing and attackers that are always trying to find and exploit vulnerabilities. These vulnerabilities can exist in many areas, including devices, data, applications, users, and locations. For this reason, many network security management tools and applications are in use today that address individual threats. When just a few minutes of downtime can cause widespread disruption and massive damage to an organization's bottom line and reputation, it is essential that these protection measures are in place beforehand. Now that we know a little about network security and its working, let's cover the different types of network security. The fundamental tenet of network security is the layering of protection for massive networks and stored data that ensure the acceptance of rules and regulations. As a whole, there are three types. The first of which is physical security, the next being technical, and the third being administrative. Let's look into physical security first. This is the most basic level that includes protecting data and network through unauthorized personnel from acquiring control over the confidentiality of the network. These include external peripherals and routers that might be used for cable connections. The same can be achieved by using devices like biometric systems. Physical security is critical, especially for small businesses that do not have many resources to devote to security personnel and the tools as opposed to large firms. When it comes to technical network security, it focuses mostly on safeguarding data either kept in the network or engaged in network transitions. This kind fulfills two functions. One is defense against unauthorized users, the other is a defense against malevolent actions. The last category is administrative. This level of network security protects user behavior, like how the permission has been granted and how the authorization process takes place. This also ensures the level of sophistication the network might need to protect it through all the attacks. This level also suggests necessary amendments that have to be done to the infrastructure. I think that's all the basics that we need to cover on network security, in which our next topic we're going to go through two mediums of network security, which are the transport layer and the application layer. The transport layer is a way to secure information as it is carried over the internet, with users browsing websites, emails, instant messaging, etc. TLS aims to provide a private and secure connection between a web browser and a website server. It does this with a cryptographic handshake between two systems using public key cryptography. The two parties to the connection exchange a secret token, and once each machine validates this token, it is used for all communications. The connection employs lighter symmetric cryptography to save bandwidth and processing power. Since the application layer is the closest layer to the end user, it provides hackers with the largest threat surface. Poor app layer security can lead to performance and stability issues, data theft, and in some cases, the network being taken down. Examples of application layer attacks include distributed denial of service attacks or DDoS attacks, HTTP floods, SQL injections, cross-site scripting, etc. Most organizations have an arsenal of application layer security protections to combat these and more, such as web application firewalls, secure web gateway services, etc. Now that we have the theory behind network security has been covered in detail, let us go through some of the tools that can be used to enforce these network security policies. The first tool to be covered in this section is a firewall. A firewall is a type of network security device that keeps track of incoming and outgoing network traffic, and it decides which traffic to allow or deny in accordance to a set of security rules. For more than 25 years, firewalls have served as network security's first line of defense. They provide a barrier between trustworthy internal protected and regulated networks from shady external networks like the internet at some point. The next tool which can be used to bolster network security is a virtual private network, or VPN for short. It's an encrypted connection between a device and a network via the internet. The encrypted connection aids the secure transmission of sensitive data. It makes it impossible for unauthorized parties to eavesdrop on the traffic and enables remote work for the user. The usage of VPN technology is common in both corporate and personal networks. Next, we cover the importance of intrusion prevention systems in network security, or IPS frameworks. An intrusion prevention system is a network security tool that continually scans the network for harmful activity and responds to it when it does occur by reporting, blocking, or discarding it. It can be either hardware or software. It's more sophisticated than an intrusion detection system or an IDS framework, which can just warn an administrator and merely identify harmful activities, while in the case of an IPS, it actually takes against that activity. The next tool in this section and the final one are going to be behavioral analytics. Behavioral analytics focus more on the statistics that are being carried over and stored through months and years of usage. Once some kind of similar pattern is noted, where the IT administrator can detect some kind of attack, the similar attacks can be stopped and the security can be further enhanced. Now that we have covered all that we need to know about network security, the necessary tools, its different types, etc., let's go to the benefits of network security as a whole. The first, which is protection against external threats. The objective for cyber assaults can be as varied as the offenders themselves. Although they're typically initiated for financial gain, whether they are industrial spies, hacktivists, or cyber criminals, these bad actors all have one thing in common, which is how quick, clever, and covert the attacks are getting. A strong cybersecurity posture that considers routine software updates may assist firms in identifying and responding to the abuse techniques, tools, and the common entry points. The next benefit is protection against internal threats. The human aspect continues to be the cybersecurity system's weakest link. Insider risk can originate from current or former workers, third-party vendors, or even trusted partners, and they can be unintentional, careless, or downright evil. Aside from that, the rapid expansion of remote work and the personal devices used for business purposes, while even IoT devices in remote locations, can make it easier for these kind of threats to go undetected until it's too late. However, by proactively monitoring networks and managing access, these dangers may be identified and dealt with before they become expensive disasters. The third benefit is increased productivity. It is nearly impossible for employees to function when networks and personal devices are slowed to a crawl by viruses and other cyber attacks during the operation of website and for the company to run. You may significantly minimize violations and the amount of downtime required to fix the breach by implementing various cybersecurity measures such as enhanced firewalls, virus scanning, and automatic backups. Employee identification of possible email phishing schemes, suspicious links, and other malicious criminal activities can also be aided by education and training. Another benefit is brand trust and reputation. Customer retention is one of the most crucial elements in business development. Customers today place a premium on maintaining brand loyalty through a strong cybersecurity stance, since this is the fastest way to get other businesses back, get referrals, and sell more tickets overall. Additionally, it helps manufacturers get on the vendor list with bigger companies as a part of the supply chain, which is only as strong as its weakest link. This opens possibilities for potential future endeavors and development. That's all really for the theoretical part of network security. After covering so many topics, let's go through a small demonstration to drive home this topic's importance. So one of the first things we're going to cover is the installation of Nmap. What we're using right now is actually VMware, where we are running an instance of a Linux distribution known as Parrot Security operating system. The Parrot Security OS is a Debian-based Linux distribution that is catered more towards ethical hackers and penetration testers. How it is catered more is it comes pre-installed with a lot of tools that ethical hackers need, including Nmap. So let's say you're using another Debian-based Linux distribution. If you want to install Nmap, you can go with the command of sudo apt, which is the package manager, install Nmap, and just press enter. At this point, it's going to ask you for your administrator password because of the sudo command which you have used. Now this apt will change depending on the distribution. Let's say using a distribution that is based on Arch Linux, that will be different. If there is some other distribution which is built from scratch, the commands will differ. But more or less, a lot of the distributions, the mainstream distributions that people use like Ubuntu, Zorin OS, Max Mint, they are Debian based. So you're just going to be using sudo apt install nmap. If you give your administrator password here, it's going to see that nmap is set to manually install and it is already the newest version. At this point, if you do not have nmap in your distribution, it's going to install the necessary package files. If I just use the nmap command, you can see some helplines where it basically says what kind of flags you can use, what are some of the most common commands, the version, etc. It gives a small sample for the usage of nmap. Now, one of the most basic functions of nmap is to identify active hosts on your network. Nmap does this by using a ping scan, or sometimes it's called a ping sweep. This identifies all of the IP addresses that are currently online without sending any packets to these hosts. To run the command, we're just going to go with, let me just clear the screen for now. Okay. Another thing you have to do before running nmap, just for our ease of use, is we're going to use the sudo su command. This will turn our console into an administrator console. So let's say we want to use some drivers or some external adapters or anything that requires administrative permission. We don't have to use the admin password again and again. Just going to give it a bit of time for it to recognize. Great. Now that you see, this $sign has changed into a hash symbol, which means we now have root access of this console right now, of this terminal. So what we're going to do for the ping sweep, where we have to check existing hosts, is we're going to use the command nmap -sp and go with the IP address of the current subnet that you're in, which is always going to be which is always going to be 192.168.1.1 in the 24 bracket. So this is going to take some time, considering this is going to check all the hosts in this particular subnet. The command then returns a list of hosts on your network, which is this, and the total number of assigned IP addresses. If you can spot like any IP addresses that you cannot account for in your network or your server, you can then run further commands to investigate them further using nmap itself. Now coming to another feature of nmap, which is a very important usage, is when scanning hosts, nmap commands can use server names, IP addresses, or even IPsec addresses. A basic nmap command will produce information about the given host. So to run a basic port scan, we can just use the nmap command with the IP address of the device or the IP address that we are targeting. So for now, the host machine that I am using currently has this current IP address. If you can see, the current IP address is 192.168.1.22 as it's written in the IPv4 address preferred section. So now we're going to try and attack this host machine using nmap on Parent Security operating system. So we're just going to go with the nmap 192.168.122 and press enter, and it's going to start scanning the host for different services and the IP address that are being run on the system. The speed of these scans usually depend on how quick the processor is and also how quickly the two machines can connect with each other. By the two machines, I mean the virtual machine in this case and the machine that is being attacked, which is right now the host machine, which is running VMware Workstation. As you can see, the host scanning is complete for this particular IP address, and you can see the number of ports is mentioned and the services that these ports are used for is also mentioned. It says which of these are open. For example, the 53 TCP port, we can see it is closed, while some of the other ports are open. Now, one more feature of nmap is the ability to guess the operating system of the IP address that we are attacking. For that, we need to add one more flag, which is going to go with the normal command is nmap -o and the regular IP address that we are in the process of attacking. Just give it a few minutes to run the scan, and it will try and put a small guess on the operating system that this host might be running. This guess might not always be accurate, but it puts a small idea, and this is much more accurate in the case of actually Unix-based operating system other than Windows-based operating systems. It may be able to detect that if it is a Windows, a Linux, a Macintosh, and so on, but it may have difficulty finding exact single versions, which becomes easier in the case of Linux because we can identify different distributions by some of the kernels, most of the vulnerabilities comes from the kernels and not the particular distributions. As you can see, the OS detection guess is complete, and you can see aggressive OS guesses over here, which is Microsoft Windows XP Service Pack or Windows Server, and there's a 98% guess that is mostly like I mentioned, if you can guess if it is a Windows-based system, you can apply the vulnerabilities and the exploits accordingly. Now, at times you may need to detect service version and similar information from these open ports actually. This is useful for troubleshooting and scanning for vulnerabilities or locating services that need to be updated, considering a lot of the newer updates are used to fix these kind of open vulnerabilities. So the flag that we're going to use in this case is -SV or -SV. That's the only thing that's going to change, but the nmap and the IP address of the host system staying consistent. A lot of the services that are being run on these ports are often not the most safe. For example, Apache Web Server, which is a very common web server being used for even local and global projects. A lot of the older versions used to have systems that can allow privilege escalations or other vulnerabilities that can allow hacker to get into your system without even you getting a trace of it. So the updated versions tend to fix these as quickly as possible, and most of these versions do not circulate in the real world, but can be used for ethical hacking and testing on how these vulnerabilities can be attacked further. Now with the SV command scan is complete, we can see that it is mentioning some of the version of the services that are being run on the particular ports. Once again, like I mentioned, using these version numbers, you can identify particular vulnerabilities and use the exploits designed for these vulnerabilities to gain access to the system. Another thing that Nmap does well is port scanning. It's one of the basic utilities actually that Nmap offers, and consequently, there are a few ways that this command can be customized further. For example, to start a port scan, we're going to use the flag of -p. We're going to specify a random port, for example 443, which we know it will be open because it is the port used for HTTPS connections, which is obviously essential for you to access the internet. And once again, we are going to use the IP address of our local host as the test machine that are being attacked. As you can see, it clearly states that the 443 port is open as expected. Now you can use multiple ports. You can check multiple ports this way. For example, nmap-p, we're going to scan 3 different ports: 443, 80, and 445. We use the same IP address again, and it's going to show the state of all the 3 ports. Now you can see this filtered part here, which does not mean it is open and it cannot be exploited in any way, at least right now. Maybe if there is any other service that is being run, it can be exploited further, but right now it is in a filtered condition. This is how we can actually scan for multiple ports together. We can also use actually in a port scanning in a range format. For example, let's say we're going to scan the ports from 200 to 300. And once again, we're going to use the -p flag, and then the IP address of the system being attacked. It's going to scan all the ports from 200 to 300 and mention what are the ports that are open, filtered, or just straight up closed. As you can see, all the 101 scanned ports are in ignore state. For example, if we try to scan a range in a more reasonable range, for example, 443 to 446, that's it. We'll keep the IP address similar. And you can see 2 of them are open and 2 of them are filtered for different reasons. This is how you can find out which of the ports are liable for exploitation before attacking these kind of devices.
During data transmission, there are various external factors which can affect the transmission of data over a network channel. To prevent such cases from happening, we use Internet Protocol Security, which we will be discussing in the session on IPsec Explained. Hi guys, and welcome to yet another trusting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to not miss an update from us. Now without further ado, let's take a look at the agenda for this session. To begin with, we will look into what is IPsec. Continuing with why do we use IPsec in a network, followed by components of IPsec, modes of IP security. As for the last topic, we will look into working steps involved in IP security. Let's begin with the first heading, that is, what is IPsec? IPsec, Internet Protocol Security, is defined as a set of framework and protocol to ensure data transmission over a network channel. This protocol was initially defined of two main protocols for data security over a network channel, which were authentication header, which is responsible for data integrity and anti-replay services. And the second protocol is encapsulating security payload, in short ESP, which includes data encryption and data authentication. Now let's move on to the next heading, that is, why do we use IPsec in a network? IPsec is used to secure sensitive data and information, such as company data, clinical data, bank data, and various sensitive information regarding an institution, which are used during data transmission over a network channel. The use of VPNs, that are virtual private networks, and apply IPsec protocols to encrypt the data for end-to-end transmission. Let's continue with why do we use IPsec services. IPsec is also used to encrypt data for application layer in the OSI model and provide security for sharing data over network routers and data authentication. Let's take a look at the working of IPsec services. To begin with, we have two different systems, System 1 and System 2, which will establish a network channel, and then the encryption of data will take place when one host will share the data to the second host. During this, IPsec services will secure the data that is to be transferred over the network channel by applying router encryption and authentication. Now let's move on to the next topic, that is components of IPsec. The IPsec services comprises of multiple protocols that ensure the data transmission over the network channel. The first one is Encapsulating Security Payload Protocol, in short ESP. This protocol of IP security provides data encryption and authentication services, and it also authenticates and encrypts the data packet in the transmission channel. Moving on, we have Authentication Header, in short AH. Similar to ESP, the authentication header also provides all the security services, but it does not encrypt the data. It also protects the IP packet and adds additional headers to the packet header. The modified IP datagram looks this way, where the IP components are included at the second position, the seventh position, and the sixth position, along with the authentication of data services over the network channel. Moving on, we have Internet Key Exchange, IKE. This protocol provides protection for content data and also changes the attribute of the original data to be shared by implementing SHA and MD5 algorithms. They also check the message for authentication and then only is forwarded to the receiver side. For example, this is the original data packet we are used to with IP header path, TCP UDP and data. Whereas this is the modified IPsec data packet where a ESP header is added between IP header and the TCP protocol. Now let's move on to the next heading, that is modes of IPsec. There are basically two types of IPsec modes available for data transmission over the network channel, where the first one is tunnel mode. This mode of transmission is used to secure gateway to gateway data. It is applied when the final destination of the data is to be connected to a sender side through a connection gateway over the internet. For example, we have two hosts, host A and host B. Through the host A, we are sending a message to host B, which will pass through a gateway at host A point, and it passes through a gateway to host B then. This is a basic format for gateway to gateway data transmission. And the given IP datagram format is used for tunnel mode. Now let's move on to the second mode of IPsec, that is transport mode. This mode of IPsec is used to protect protocols like TCP or UDP and is used to ensure end-to-end communication unlike tunnel mode. The transport mode data at authentication header and encapsulating security payload for security purpose in the IP header. This is the modified IP datagram for transport mode. The point to be noted is the IPsec header is always added between IP header and TCP header. Now let's move on to the last heading for this session on IPsec, that is the working steps involved in IP security. In general, there are 5 steps involved in the working of IPsec to ensure data transmission over a network channel. The first step is host recognition. In the first step, the host system will check if the packet is to be transmitted or not by automatically triggering the security policy for the data, which is implemented by the sender side for proper encryption. Then the second step is known as IKE phase 1. In this step, the two host devices, the sender and the receiver side, will authenticate each other to establish a secure network channel. It is comprised of two modes. The main mode. This provides much better security with a proper time limit. And the second mode, known as aggressive mode. As the name suggests, it establishes the IPsec protocol much faster in comparison to main mode. Let's move on to the third step, which is IKE phase 2. After the second step, the hosts decide the type of cryptography algorithm to apply over the session in the network channel and the secret key for the algorithm to be used to encrypt the data for transmission. Then we have IPsec transmission. This step involves the actual transfer of data over the network channel using the various protocols used in IPsec security, which are implemented under the tunnel condition. And the last step is IPsec termination. After the completion of data exchange or session timeout, the IPsec tunnel is terminated and the security key established is discarded by both the host system. In this video on Dijkstra's algorithm, we will learn details regarding the network algorithm used in multiple applications to connect a channel's node. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is the algorithm. Moving on with key points regarding the algorithm. Continuing with the principle used in the Dijkstra's algorithm. As for the last topic, we will look into a solved example using the Dijkstra's algorithm. Let's move on to the first topic, that is Introduction to the algorithm. The Dijkstra's algorithm was invented by Edgar W. Dijkstra. This algorithm was designed to find the shortest path between the nodes of a communication channel. The Dijkstra's algorithm is also used to form a shortest path table for the given graph, and it works on the principle of greedy algorithm. Now let's move on to some key points regarding the algorithm. The first key point to be noted to solve a Dijkstra's algorithm is the algorithm is closely linked to position of the nodes in a graph. The next point is the attribute value between the nodes of a channel is used to deduce the shortest path. As for the last point, we have the initial value of all the nodes from the current node is assumed to be infinite. To much practically understand the functioning of the Dijkstra's algorithm, let's take a look at the principle for the same. The principle of the algorithm works as if the distance of u that represents the current node plus the length that is the attribute value between node u that is the current node and node v that is the target node is less than the attribute value to distance of the target node. And also, the distance of the target node is equal to the distance of current node plus the length between target node and the current node, where distance u represents the source node or the current node, and distance v represents the target node or the destination node. To much better understand, let's apply this. For the given question, let's find the shortest path. In this given example, we have three different nodes, node A, B, and C. Using the previously discussed algorithm principle, we will deduce the shortest path for node A to the other nodes in the graph. That is, the shortest path from node A to node B and the shortest path from node A to node C. For this, let's take the node B first. According to the solution, it should be for node B, on applying the algorithm along with the values, we have if 0, that is the position of A, is 0, plus the target node attribute value, that is 10, is less than equal to infinite. That is, initially as mentioned, infinite value is to be assumed. And this statement stands true. So the distance between node A to node B becomes 10. For the third step, we will look into distance between node A to node C. That would be 0 plus 40. That is the direct connection between node A to node C according to the example, which is less than infinity, again true. So the distance between node A to node C is 40. Moving on, but we have to find the shortest path. So for this, fourth step comes into picture. That is, for node C from node B, on applying the algorithm we have 10, that is the initial value of node B, and plus 15, that is the attribute value between B and node C, which is 25 and is less than infinity. So the shortest path between node A to node C becomes 25 instead of 40, which was given through step 3. Using the same scenario and same steps, we will solve a much difficult question and understand how the algorithm is used. Then without further ado, let's move on to the solved example using the Dijkstra's algorithm. According to the given question, we have to use the Dijkstra's algorithm for the given graph and find the shortest path from node A to node C. The point to be noted is we need to find distance that is shortest between node A to node C only. Now let's take a look at the graph, and this is the given graph with node A at the current node and node C is to be the targeted node. But before we begin with the solution for the given graph, let's take a look at some of the important points to remember. The first point, the distance of node A from all the other nodes is infinite in the starting step, as discussed earlier in the example graph. The next point is, the node with the shortest value will become the next current node. Then we have, this graph is done to maintain a proper shortest path value table, which will be very helpful during the solution of the graph. Now let's move on to the solution. To begin with, we will make shortest path table value, that is given through this, with 3 columns in it: node column, value column, and previous node. Now let's start with the actual solution. To begin with, the first step is to mark the current node, that is node A. Then the nodes that are directly connected to the current node, that is node B and node D. Now, using the value distance, that is 3 for node A to node B and 8 for node A to node D, we will update our table, where the point to be noted is that we have updated the previous node as A for both the nodes B and D. Moving on, now let's choose the next current node, that is node B for the next case, because the shortest path in the given table is 3, which is less than 8. Now, the directly connected nodes to node B are node D and node E. Similar to the case we did earlier, we will mark the shortest distance from node B to node D and node E. Let's deduce the distance. The distance between node B to node D is 3 plus 5, that is equal to 8. And then we have distance from node B to node D, that is 3 plus 6. So the value is 9. Now we will update our shortest path table, and the new table comes up to be from node D to node B we have 8, and node B to node E we have 9, with the previous node as B. Moving on, let's decide the next current node, that is D, because the shortest distance is 8 in comparison to 9 for node E. So the new current node is node D, and the directly connected nodes to node D is node E and node F. The point to be noted is the current node is chosen only from the unvisited nodes. Now, for this we have distance between node D to node E is 8, that is the previous value we deduced, plus 3, that is the distance between node D to node E, and the total value comes up to be 11. Then we have to node F from node D, that is 8 plus 2, that is the distance between node D and node F. So the value becomes 10. On updating the shortest path graph table, we have the new distances, that is node F has 10 value with the previous node as D, and there is no change with the node D, because in comparison to 8, 11 is much bigger. Moving on, let's choose the next current node, that is node E, because in comparison to value 10 from node F, 9 is smaller. Now the node E is a current node, and the directly connected nodes are node F and node C. Now let's find the value between node C and node E. That will be 9 plus 9, that is the distance between node E and node C. So the value totals come up to be 18. And for node F and node E we have 9 plus 1, that is the distance between node E and node F. That comes up to be 10. Now let's compare with the graph table, where node F is originally at value 10, and again the value is 10, so there's no change. And C we have infinite, and the value 18 is much smaller, so the new graph would be something like this, with node C as 18 value and previous node as E. Now let's decide the next current node, that is node F, because the distance value is lowest in the given graph, that is 10, and for node C is 18, and the directly connected node is node C. Then the distance comes up to be 10 plus 3, that is 13. Using this 13th value, we can decide the current value of C is 18 and the new value is 13. In comparison, 13 is obviously less. So the new graphs comes out to be for node C value 13, and the previous node becomes F. With the completion of all the nodes in the given graph, we can deduce the shortest path from node A to node C. That comes up to be from node A to node D to node F, and node F to node C. And the total value comes up to be 13. With this, we have covered all the parts regarding the functioning and the working steps involved in the Dijkstra's algorithm. With the increase in the data exchange between multiple devices over the network channel, we need algorithm to control the error and the damage done to the data being transferred over the network channel, where checksum plays an important role. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to miss an update from us. Now without further ado, let's take a look at the agenda for today's session. To begin with, we will look into what is checksum. Continuing with why to apply checksum method in a data exchange. Continuing with working steps involved in the checksum, and in the end we will look at a solved example for the same. Now let's take a look at the first setting, that is checksum. The checksum is one of the most applied error detection method in the network channel and is a bit-based format detection method. The checksum uses checksum generator on the sender side to perform the checksum method and the checksum checker on the receiver side to check whether there is an error in the data or not. Let's continue with the next setting, that is why to apply checksum method. Using the checksum method at the sender side, the checksum value is added to the original data to be transferred as an error detection method, whereas at the receiver side, it decodes the incoming data from the sender side according to the checksum method to detect any changes in the given data. Now let's move on to the working steps involved in the checksum method. There are various steps involved in the checksum method. Let's take a look at the first step, that is, the first step begins at the sender side, where we divide the original data into k parts of n bits, continuing with adding all the k blocks we have obtained. Then the addition result is complemented using 1's complement. The data now obtained is known as the checksum value. Next, let's look at the step 2, data transmission. After we have received the checksum value from the checksum method, we will add it to the front of the original data and transfer it to the network channel to the receiver side. Now, step 3. Step 3 begins at the receiver side. That is, the receiver side will divide the obtained original data plus the checksum value into k blocks and then add all the k blocks using addition. After that, we will complement the obtained data. If the complement of 1 comes out to be 0, that is, no errors are received in the data and the receiver will accept the data. Whereas for case 2, if the result is not 0, the received data is damaged. So the receiver will discard this data and request for retransmission of data from the sender side. Now, after understanding all the points regarding working of the checksum method, let's take a look at a solved example to better understand all the points. The question is, for the given data, perform the checksum method. This is how we divided all the 4 parts. Each of these represents a k block, that is 4 blocks, and 8 bits in each of the block, that is n bits. Now for the first step, that is at the sender side, we will add all the given data. So the value would come out to be 1000, that would be 1, 0100 would be 1, 0011 would be 1 carry 0, so 1 carry plus 1 means 0 plus 1 carry again, 1 carry plus 1 means 0 and 1 carry again, 1 0 1, that is 1 carry 0 plus 1 plus 0 means 1. So 1 carry is over on this side. 1 plus 0 is 1, 1 plus 1 is 1 carry 0, 0 plus 0 is 0, 0 plus 0 is 0 and 0. And we have 1 carry over here. So the obtained data would be 1 0 with extra bit as this. Now to resolve this issue, we will now add the extra carry to the obtained data from the addition part. That would be 1 0 1 0 0 1 0 0. Now at the sender side, we will do 1's complement for the obtained addition value. That would come out to be 110 11010. That is the checksum value. Now this value addition to the original data will be shared to the receiver side, where at the receiver side we will again perform the addition method, and the value comes out to be this, along with 2 digits of extra bit, that is the carry. Again, similarly, we will add this carry to the addition value and get the new data, that is all ones. Now again, going by the steps, we have to perform 1's complement for this value obtained. That comes out to be all zeros. That means the checksum value is 0 at the receiver side, which indicates that there are no errors in the received data by the receiver side. With this, we have completed all the points regarding working of the checksum method. Now, to better understand all the steps, let's take up a quiz. That is, for the given data, find the checksum value, where the given options can be one of them. You can give your answers in the comment section.
In recent years, the cost of data breaches has steadily risen. The additional vulnerabilities that occur due to the move to a remote workforce dramatically enhance the chances for cyber attacks and introduce several weak points for hackers to exploit. Additionally, automated hacking assaults and the capacity to exchange bitcoins via ransomware have increased the cost of cybercrime in general. Companies' workforces have transitioned to full-time work-from-home models, which gives rise to new attack surfaces. Threat actors target the people who are most vulnerable by taking advantage of current events and shifting situations. To better understand this growth in digital crime, let us go through a few statistics. 2020 brought with it a slew of new problems for both businesses and consumers. In the midst of a worldwide epidemic, forest fires, and political instability, it's easy to overlook a serious, albeit less physical threat. It set a record for data loss due to cyber attacks as well as the sheer volume of attacks. 2020 is already outpacing its predecessor. The graph below denotes the percentage of companies that fell victim to at least one cyber attack in the respective year. With the numbers growing steadily, we are yet to see the true crux of this digital revolution. In situations like these, penetration testing has been a gift for organizations worldwide. While security testing cannot guarantee a 100% solution, it can go a long way in securing those critical data from falling into the wrong hands. Hey everyone, this is Vaibhav from Simplilearn. Welcome to this tutorial on penetration testing. Let's go through some of the topics we will be covering today. We start by learning about penetration testing and ethical hacking and the different use cases in the IT industry. Next, we know about the benefits of penetration testing and how they help organizations save money in the long run. Moving on, we familiarize ourselves with the different types of penetration testing or ethical hacking, with each serving a different category of personnel. In the next section, we read about the 5 distinct phases in every ethical hacking campaign and how they help clear up the extensive report at the end of every penetration testing session. Finally, we have a live demonstration on how we can check for vulnerabilities and the ways hackers can break into devices without adequate security measures in place. Let's start by learning about penetration testing in general. Organizations can define penetration testing based on the objectives of the test. All networks, applications, devices, and physical security components are included. It imitates the behavior of harmful individuals or the hackers. Experienced cybersecurity specialists use penetration testing to strengthen a company's security posture and eliminate any weaknesses that leave it vulnerable to attacks. Penetration testing, when done correctly, goes beyond simply preventing thieves from gaining unauthorized access to a company's systems. It generates realistic scenarios that demonstrate how well a company's present defenses might perform in the face of a full-scale cyber assault. The simulation aids in the discovery of the sites of exploitation and the testing of IT breach security. Businesses may acquire professional, unbiased, third-party input on the security procedures by conducting frequent penetration testing. Pen testing, while relatively time-consuming and costly, can aid in the prevention of highly destructive and expensive breaches. A white hat hacker employs hacking talents to find security flaws in hardware, software, or networks. On the other hand, white hat hackers follow the rule of law when it comes to hacking instead of black hat hackers. They assist firms in conducting penetration tests to analyze their security index and make the necessary improvements. Ethical hacking provides a full audit of your security policies and, in the case of bug bounties, can assist you in identifying holes in existing operational systems. It takes a far broader approach to cybersecurity than penetration testing. Whereas penetration testing focuses on system flaws, ethical hacking allows actors to utilize any attack tactics available to them. They can take advantage of system misconfigurations, send phishing emails, launch brute force password assaults, breach physical boundaries, or do whatever else they feel will get them access to critical information. Because thieves are progressively changing up the approaches and launching multi-layered complex attacks, this is incredibly useful for determining just how exposed the organization is to cyber threats. Considering the vast domain that is ethical hacking, we have multiple categories of penetration testing methodologies. Let's cover them in the next section. When configuring a security system, testing is critical to preventing hackers from penetrating the perimeter. There are three sorts of tests: black box, gray box, and white box. In the black box testing, the tester receives no information during the penetration test. In this case, the pen tester takes the method of an unprivileged attacker from initial access and execution until exploitation. This scenario is the most realistic, showcasing how an attacker with no inside knowledge may target and compromise an organization. However, because of this, it is also the most expensive alternative. White box penetration testing, which is also known as crystal box testing, entails sharing all network and system information with the tester, which includes network maps and passwords. This saves time and lowers the overall cost of a project. A white box penetration test effectively simulates a focused assault on a given system using as many attack paths as feasible. In a gray box penetration test, also known as a transparent box test, very restricted information is present with the tester. Gray box testing is beneficial for understanding the extent of access a privileged person may get and the possible damage they could wreak. Gray box tests achieve a mix between depth and efficiency and may be used to mimic either an insider danger or an assault that has infiltrated the network perimeter. Now that we covered the basics of penetration testing and their relative categories, one must know how these testing campaigns benefit the organizations conducting them. Let us go through a few perks of penetration testing. Regular penetration testing helps your business assess the security of online applications, internal networks, and external networks. It also assists you in understanding what security measures are required to achieve the degree of protection your company needs to protect its people and assets. Prioritizing these risks offer firms an advantage in anticipating hazards and preventing harmful assaults. Penetration testing is similar to a real-life hacker rehearsing for a real-life hack. Regular penetration testing helps you be proactive in your real-world approach to reviewing the security of your IT infrastructure. The process identifies gaps in your security, allowing you to correct any flaws before an actual attack happens. It is undeniably expensive to recover from the effects of a data breach. Legal fees, IT cleanup, consumer protection programs, lost revenue, and dissatisfied customers may cost businesses millions. Penetration testing regularly is a proactive strategy to remain on top of your security and may assist in preventing financial damage from a breach while safeguarding your brand and image. Penetration testing aid in meeting the compliance and security duties imposed by industry standards and regulations such as PCI, HIPAA, FISMA, and ISO 27001. Having these tests done regularly help demonstrate due care and a commitment to information security, all while avoiding the significant fines associated with the non-compliance. With the entire process seeming to be a lengthy ordeal, what are the multiple phases in the process? Theoretically, we have to follow a 5-stage process. Reconnaissance is the first phase of the penetration test. In this phase, the security researcher collects information about the target. It can be done actively, meaning you are collecting information by sending a request directly to the target and interpreting it. Passively, where you are collecting data without contacting the target, or both. It helps security firms gather information about the target system, network components, active machines, etc. This activity can be performed by using information available in the public domain and using different tools. The scanning phase is more tool-oriented rather than performed manually. The penetration tester runs one or more scanner tools to gather more information about the target. By using scanners such as war dialers, port scanners, network mappers, and vulnerability scanners, the penetration tester collects as many vulnerabilities which help in turning to attack a target in a more sophisticated way. The third phase is gaining access of the system. In this phase, the penetration tester tries to connect with the target and exploit the vulnerabilities found in the previous stage. The exploitation may be buffer overflow attacks, denial of service DOS attacks, session hijacking, and many more. Pen tester extracts information and sensitive data from the servers by gaining access using different tools. In the fourth stage, the hacker has to maintain access. The penetration tester tries to create a backdoor for himself. It helps the penetration tester to identify hidden vulnerabilities in the system and can later access the machine should the need arise. In the final phase of clearing and covering tracks, the penetration tester removes all logs and footprints which help the administrator identify his presence. This allows the penetration tester to think like a hacker and perform corrective actions to mitigate those activities. With the cost of cybersecurity platforms going up, trained penetration testers receive an excellent level of remuneration for their efforts. As per reports, the average yearly salary for a penetration tester is 6 lakh Indian rupees or $110,000 in the American counterpart. Finally, let's go over some of the ways hackers can identify vulnerable positions on a system to gather information in a live demonstration. In this demo, we will start by setting up a VPN connection that will allow us to access to a vulnerable network by creating a local virtual group over the internet. We then try to scan the victim machine for breachable entry points, find the username and password of the user in question, and eventually grab the root password from the device. To start our demonstration, we're going to need a vulnerable machine to work on. Now this vulnerable machine can be found on the website known as TryHackMe, which is a service catered towards penetration testers. Before we connect to the machine, we need to join the network where the machine is located. We can do that using an OVPN file, which is short for OpenVPN protocol. To connect to this OVPN file, we're going to go into a new workspace on Parrot Security. We're going to activate the root access and we're going to connect to it. hacktest.ovpn. Once we see the message initialization sequence completed, we can be sure that we have connected to the network which has the vulnerable machine. Now to start the vulnerable machine, we're going to click this button and wait for a few seconds. As you can see, it gives a 1-minute countdown before it shows you the IP address. Now remember, whatever the IP address we receive here, it is a machine being launched on the TryHackMe servers, but we can access that machine because of the OVPN connection that we have just set up using this file. This OVPN file can be found on the TryHackMe servers profile section, which I downloaded beforehand. As you can see, we now have the IP address of our victim machine. Let's try if we can reach this machine or not. We're going to copy the IP address and we're going to try and ping to the machine. If the connection is successful and we have joined the network, we should be able to see some response over here. As you can see, we're receiving request pings from the victim machine, which means that we have already joined the victim network. Now that we are confirmed we are able to access the vulnerable machine, let's run the first step in a penetration testing, which is reconnaissance. Let's run up nmap scan. We're going to use the flag of SV so that we can know which version of the service it is running. We're going to take up the IP address and paste it here. This scan will only be possible if the OpenVPN connection is up and running. As we can see, it is still running. And we have our results over here. We're running the scan so that we can find the services running on the host machine that we will run nmap against. We conclude that a web service is running actually on port 80, as we can see over here, which is using the Apache server system. In addition to this, there is a SMB Samba service as well, running on ports 139445. Now that we know we have an Apache server, we can use this IP address to open it on the browser. Okay. Since the current homepage is not accessible, we can use some other URLs as well. As far as Apache servers are concerned, there are a certain set of URLs that can be used to open. However, if we go to the URL, which is IP address / development, this opens up a new folder. If we try to check the contents of these files, this is for the dev.txt. You can see the version of the Apache HTTP server that is being run. This is the dev.txt. If we go back and we check the second file as well, it says the contency shadow has the credentials. Okay, if we go back again, SMB has been configured, which we have already found at nmap that it is running a Samba server. Now, with this version of the Apache server, we can find version specific exploits that can be run on Metasploit, but there is sometimes no need of that. We can use another technique, as we now know that there are multiple users that is being run over here. We can use a tool known as enum for Linux. What it does is acts and enumerates the Windows and Samba systems. To run that command, we're going to use enum for Linux -a, and we're going to take IP address of the machine. I'm going to paste it here. What this will essentially do is provide us usernames that are being stored in the victim machine. It's going to take some time to find out the usernames. Once we find those out, we can run the necessary attacks. As we have already seen on the nmap, it is also happening in SSH port. So if we find the username and we find a single hash that can be cracked, we can use the SSH to get inside the machine. Right now, we have to wait for the results of the enum for Linux command. As you can see, we have found two users of the machine known as K and Jan. I think we can stop the enumeration right now since we have the two users of this machine. Next step, what we can do is we can try to SSH into the machine. Now to run the SSH command, we're going to need the password of one of the users. For this example, let's say we go with the user of Jan. To brute force, we're going to use the Hydra tool. This is like an example command. This is how we can use. Let me just copy this and paste it over here. All right. Hydra -l user, as we had already decided, we're going to use the user Jan, and we're going to use SSH. For the IP address, we're going to copy it from here and paste it here. Now for the password list, we're going to use a word list which has a few passwords already present in it. For this example, I'm going to use the rocku.txt file, which has like millions of passwords already stored in it. What the Hydra will do is it will try to bypass the SSH console on the machine using the passwords present in the rocku.txt file. We will give the path of rocku over here like this. And we're going to run it. As you can see, it's mentioned that it's attacking SSH at this IP address. Now this attack is going to take a while, and after this attack is done, we are going to get the SSH password, which is basically the credentials of the Jan user in the victim machine. For now, I'm going to stop this attack. What I would recommend is for you to run this attack and write down the password that you received in the comment section below. The password that we receive from here can be used to log in into the machine. Let's try that once. To SSH into the machine, we're going to write SSH user @IP address. We're going to write yes and press enter. Now we're going to enter the password that we have found after running the Hydra command. I'm going to type the password and press enter. And we have logged in, as you can see. Now, if we try to look around, there are no directories over here. Okay, so let's go one step back. Give a space over here. Okay. Let's go to the second users folder. Okay. These are the contents of the K folder, and you can see there's a .ssh folder over here. So we're going to enter that. Let's have a look the files in this folder, and we can file an RSA ID over here, which, if I'm not wrong, should be an RSA private key, which can be used to SSH into the machine. Here we go. You can see it's a begin RSA private key, and it should end here as well. Now what this private key does, this hash will be used to log SSH into the machine when using the user K. Once this hash is cracked using Hydra or any other cracking software like John the Ripper, we can easily use the passphrase to log in into the machine with the user of K. What I am going to do is copy this private key . I'm going to launch a new terminal. I'm going to create a new file known as nano ID, paste the private key over here, and save it. As you can see, we have saved the file over here. Now this hash can later be used to crack into the machine using the user of K. This hash can be cracked using either John the Ripper, Hydra, or there are other cloud mechanisms that can be used to crack this machine. After it is cracked, we can use the passphrase derived from it to SSH into the machine. To perform the SSH entry, we're going to use this command, SSH-i. We're going to use the same file which we received. We're going to write the username, which is K 10.10. We can just copy it from the here, right? Minimize this and paste the IP address over here. Or we can do one more thing. We're going to use the sudo command together as well. It's better. Sudo SSH, enter the system password. This passphrase is the one that we received after cracking the hash in this ID file. Whichever password you received after cracking this using Hydra or John the Ripper, please write the password in the comment section so that we can know that we have successfully cracked the password. We're going to write the passphrase over here, press enter, and as you can see, we have entered the system of K. Here we're going to press ls and we find the backup file of the password. We're going to write cat pass.back and here is the final root password. So as you can see, we have now received the final root password of the primary user, and we have already cracked the password of the other user, that is Jan. So this is the entire process of how you can use Nmap to find out the vulnerable points. You can see which are the softwares that are running, which versions they are running, and which of those versions have a legitimate claim as an insecure exploit.
So guys, we have come to the end of our full course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.